Good morning, everyone. Good morning. Welcome to this 98th edition of the Zak World of Façades conference. My name is Ahmed. I'm part of the organizing committee of this event. So glad to host all of you once again in person. I'll give you a quick introduction about the Zak World of Façades conference series before we move on. So we started the Zak World of Façades conference back in 2012, so it's 10 years for us now doing these events, minus the 1 year of 2020 in COVID where we couldn't pull off a single event. But anyways, those challenging days are behind us now. We have events all across the globe, right from New Zealand up until Canada. These are one-day conferences talking about the best practices in designing, engineering, installing doors, windows, and facades. So that's our specialty. We've been extremely privileged to have support from the industry speakers, product manufacturers, contractors across different countries. In Saudi Arabia, this is our fourth event. We did our first event in Riyadh in 2017, second one in Jeddah. It was a different Saudi at that time, and it's a different Saudi now. We did one in Riyadh in 2019, and of course, this event was originally planned for 2020. I think it was jinxed 3 times. We had to postpone this event for various reasons, either COVID or some restriction, or the government taking away the hall last minute. So I didn't even believe at one point in time we would execute this event, but finally we are here. So I'd like to thank our sponsors for their patience, our speakers, multiple date changes, but I'm happy all of them are here now, and you'll have a great agenda today. So as I mentioned, this is a one-day conference. We've got 3 sessions with the networking breaks, and we've got a final networking at the end of the event. We have presentations from architects, from facade consultants, from product manufacturers, all talking on different things of the building envelope. So I hope you will enjoy today's day. This event wouldn't have been possible without our support from our event sponsors. I'd like to introduce them quickly. They've been extremely patient in making this event happen, almost 2 years since we originally planned this event. So our presenting partner is Schuko. Schuko is a leading supplier of door, window, curtain wall aluminum systems. It's a German company. They're best in their business. Our associate partners, starting with Semrit. Semrit is a cladding manufacturer of fiber cement cladding. China Southern Glass is a glass manufacturer out of China. Ephesus is a Portuguese manufacturer of weatherproofing solutions. Future Architectural Glass out of the UAE is a value-added glass processor. Kinlong is out of China, one of the leading manufacturers of glass hardware, fittings, and accessories. Kurare is the mother company of the laminated glass interlayers, Trocifol, and Sentry Glass. Ozone is an Indian manufacturer of glass hardware and fittings. Saint-Gobain needs no introduction. Various of their building material products which are being used on the facade are exhibiting today, from glass to external insulated facade systems to insulation and other stuff. Siele is a specialty German contractor doing complex stuff, from structural glass elements to curtain walls to lightweight structures. Sotec is a British manufacturer of rain screen cladding. Technoform is a German manufacturer of thermal insulation solutions. They have polyamide strips and warm edge spacers. Vector Foiltech is another German manufacturer of lightweight envelope solutions of ETFE, so lightweight structures. There's a lot of focus now going forward, so you'll be hearing from them later, and others. Vitro Architectural Glass, formerly known as PPG Glass, is one of the leading high-performance glass manufacturers out of the US, and our technology partners, Orga Data. So we don't have a delegate kit this time around, but if you see your badges, the visitor badges, you will have a USB stick, which is sponsored by Orga Data. The USB stick has the brochures of all the sponsors participating today. Their brochures are in that. Our next event is, very close, in Riyadh, end of the year. Originally, both these events were almost a year apart, but then because of the numerous delays, as I mentioned, for this event, due to various reasons, the gap became very small. But of course, Riyadh is again a different market, different challenges, different set of speakers, different set of topics. So that's at the end of this year, on the 12th of December. A little bit extended into the region. We're doing our first event in Pakistan, in Karachi in January, and then of course our biggest event in the region is Dubai, which is in March. Of course, we will do many more events next year in Oman and other parts of the region, but these three are planned as of now. And yes, this is it from me. It's an opportunity for all of you to network and connect with manufacturers, with people who are designing, engineering, installing, building envelopes. So I hope you enjoy today's day. A few housekeeping rules. We won't be taking any questions, so the speakers would be around in the networking breaks. You can get hold of them and ask them questions. All our product manufacturers are having a table outside. I encourage all of you to please go visit their booths and network with them. They've been waiting, as I told you, for almost 2.5 years for this event to happen. They've been extremely patient and as well as supporting this event. So without their support, this event wouldn't be possible. So please go meet, exchange your business cards. You never know your next project. There could be a solution which they have to offer for you. So I won't take much of your time. I'd like to call upon my colleague Amro Hassan. He's going to be today's event host and convener. He's going to take this discussion forward and invite our first speaker on stage.
Dear colleagues, professors, speakers, sponsors, ladies and gentlemen, on behalf of Zak World of Façades, I would like to express my gratitude and welcome you to the 97th edition in this event in Jeddah. It is our hope that this Facades conference would be able to achieve its objective in providing an effective forum for you industry leaders and pioneers to advancing knowledge, research, and facade technology for the region. I hope that all of us can walk away from this gathering today with a better sense of how facades can contribute to a more sustainable future. Without further ado, I would like to welcome on stage our opening keynotes, Dr. Hazem Sabbagh, founder and creative director of Craft Architecture. Please, Dr. Hazem. Give it up to Dr. Hazem. Thank you.
Good morning, everybody. Thank you for being here at an early morning, and I'll try to just frame a few perspectives regarding the confluence of the notion of design in general with the potentials of the envelope from a poetic standpoint to some extent. The specifics of this conversation deals with the idea of situations, because when we do design in architecture or in the wider realm of urbanism, landscape, interior, and so on, the context within which we think, the context within which we live, the context in which we use a space is fundamentally integrative. And in that context, the notion of an envelope, the notion of a particular facade is actually much more than just a single line. It's a whole environment. So it's a threshold, it's a transition, it's a mode of expression. So this whole notion becomes a confluence of multiplicity of conditions that affect our thinking about the envelope itself, its potential performance, et cetera, et cetera. Let me just see how this works. I'm just going to go over a few values that would, in general, universally, would affect what we could think of as design frameworks, design values. So there's a notion of empathy towards our collective presence as communities, as human beings, and our empathy towards our environment, and the relationship between the two that affects the well-being of how we live as well as human beings. So that's one. The second, it's more about this whole notion of microecology within which we operate day to day. I mean, there is a bigger macro ecology that we deal with in terms of global warming, etc., but the microecology context is within which we create these solutions against which we mitigate our immediate levels of wellness and comfort and manners of perceptions. There's a notion of identity, and again, identity, it has two realities. There's a notion of an environment, and there's a notion of cultural expression. And the environment and culture creates what we might want to call environmental memories, and these environmental memories are imbued with ecological, environmental, as well as associative notions against which we sort of create our building, create our cities, and create sense of continuities in our environment, in our built environment. Any of these aspects will affect our thinking about architecture, about design in general. Obviously, how we evolve as humanity, how we evolve, is not only a matter of a utilitarian response. There is a poetic, interpretive, and conceptual abstractions to what we do. And all these sort of underlyings continue to infuse this overall potential of how we manipulate the elements by which we define our environments and create architecture, create spaces, create communities. I'm just going to read this theoretical statement. I promise you, this is the one and only theoretical statement. Architecture occupies a peculiar transitional space within ecosystems. It's an inanimate, non-biological form, yet somehow finds a way to mitigate life forms, affecting their interaction and well-being. Human contemplation in the making of shelter embodies constitutive motives through which this mitigating space is created. It can be elemental or spatial, relying on materiality, tectonics, fabrication, and construction. By default, the manners by which these come together, aesthetically and functionally composed, affects an intent that is simultaneously ecological and expressive. It becomes rhetorical, imagined, and poetic. The modern facade, so technologically biased towards modes of economy and production, perhaps misses the potential of its imagined and situational nature. This presentation will attempt to shed light on these overarching premises. And the presentation is going to go over essentially works that I have worked on over the last few years of my career. And some of these projects are with Craft that we founded a few years ago, and some are from my previous practice as design director in multiple firms as well. So it just creates a sense of an overall history, biohistory, essentially. This is a project that we're working on right now for the King Salman Nature Royal Reserve. This is in Toepfer, which is north of Tabuk, close to the boundaries, close to the boundary with Jordan. And in essence, other than the actual program that needs to happen, there are research, visitor centers, some accommodations, etc. The critical aspect of how we intended to work on this is to create a formal descriptive and an engagement that's in confluence with the natural forms. So it was quite a sort of manner by which you set a building in harmony with its environment. And then in terms of the tectonics of constructions, we're going to be working on all the sort of physical sort of wall systems are going to be rammed earth, and we're going to be sort of working those out from within the local sort of space. And we have tensile structure, low impact construction, and so on. So in this particular case, the notion of facade, the notion of materiality, and so on, fuses itself with the idea of place as such. And it goes beyond just a technical solution. It becomes the tool, the strategy by which you start creating and sculpting the architecture. This is a building that was built a few years ago here in Jeddah. Again, it has this dual presence between a Western facade that is fundamentally minimalist, but it brings a notion of, I would say, a rhetorics against the ecology and environmental performance, obviously mitigating the harsh Western sun, and then on the sort of the east-south facade, we have created multiple layers within which the envelope itself has a tectonic sort of pattern of brésolets or louvers, as well as the layer of landscape in front of that facade becomes a significant element of the design as well. So the building operates in context of how the palm trees are operating as well, in terms of filtering light and in terms of the type of environment it creates and the experience it's creating between the inside and outside of the building. So the duality of these descriptive moments are very critical. This is a project that I worked on as design director with Cassian in Vancouver. It's the Surrey City Hall. And again, there is an essence of how the facade can be sculpted and how it can sort of, the whole building form can reorient itself to open up to a public plaza space, in this case, the city center plaza, and how the sort of the transformation of the facade content from a transparent sort of louvered facade on one end, and the way it sort of sculpts itself to the west and to the north in a different manner. Again, the facade with its multiple technologies affects different readings above and beyond the pure performance. This is a LEED silver building, LEED silver building. We couldn't get the LEED gold just because we couldn't get enough geothermal sort of points at that point. But that's what happened. Obviously, this particular project was part of a wider master plan that we worked on, and the Civic Square is where the City Hall fronts, and out of these two buildings so far, the City Hall and the Public Library are already done, and things are evolving as such still as we speak. This is a view from the other end, and how the facade, nature of the facade sometimes is layered with louvers and so on to deal with particular environmental conditions. Interior space from the main public space of the City Hall towards the Public Library and the Public Plaza. Whatever we do, we have to think about wider context. This was just a mapping of an ecological space in Ha'il. This is just a fragment of perforated woods, petrified woods, my apologies, petrified woods on the site of the original project for the new American University in Cairo. We didn't win the competition, but we created an environment within which the morphology of the urban form has multiple layers of porosity against which you start building on the architecture as well. This in Cairo is under construction right now. It's a building in the new capital, new administrative capital, actually the center center primary axis actually over there. What we looked at there is how a building can capture the presence and the history of a whole country, the history of a whole land, the land of ancient Egypt, the land of the power of the mass within which you would have sort of understood the perception of those, of that particular ancient culture. And we worked out a design that fundamentally is porous at ground, so allows continuity, but then the envelope is just creates a solid mass that then just opens up. Sorry, bad with technology. That opens us within. This is an office building, yeah. So the office spaces are fundamentally opening up onto this lush court space that penetrates, where light penetrates from multiple three-dimensional points. This is the ground, the porosity in the ground. So, yeah, this is what sorry, I'm just flipping the wrong way. Yeah, so this is the last in Cairo. This is one of 3 college campuses that we designed in Al-Baha, which is like 5 hours away, south of Jeddah, drive. 3 college campuses within which we created like hearts, an environmental heart for the students' sort of life, and we created an architecture that is again minimalist, contemporary, yet has certain elements that echoes the textures of the traditional architecture, the vernacular of the place. And again, the whole notion of the envelope is always layered with transitional spaces and other treatments that allows the performance and life within each of these building spaces to be mitigated against its micro sort of site or micro situation. Let me see, left or right. Yeah. So, for example, in the college, that was the library building, the first one, and this is one of the colleges, and within the college that open up onto the sort of the morphology is a series of intersecting court spaces, but never closed. So the syntax, the morphology and syntax is always creates an open system for movement and whether environmental flow or human flow. And then the glass facade in this case sort of builds a higher layer of performance through this bracelet, which were in Teflon fabric printed, and the language that you see in terms of textures, colors, and so on come from traditional fabrics of the region. So that level of association that we build in as a manner for poetic descriptive. And we had different types of landscape and different types of colors to identify different zones and different types of colleges. There's some of the extractions that took place. A very similar exercise, but with an internal environment. This is a deanship building in King Saud University in Riyadh, and the whole building was composed as a series of blocks around an open interior space. The interior space, of course, was treated environmentally, but it acts as if it is an outdoor plaza. So we worked out on a treatment that starts fine-tuning the presence of that, and we are creating this. The envelope in this particular case becomes three-dimensional. The roof becomes part of the envelope in sense of experience as well. And and then the same notion of how the textures and ornaments that would have been extracted from traditional motifs become contemporary in infusing and informing the manner by which we're treating this internal facade, if you'd like. A very similar notion of how we're extracting certain texture. This is a mixed-use building in Riyadh. It had a hotel, it had residences, it had multiple other things. And again, the glass fret, sorry. Oh, jeez. So yeah, the glass fret mitigates scale and informs the internal experience in terms of framing your perceptions of the exterior environment, as well as it acts also as an environmental sort of filter. Is it left or right? Sorry. Yeah. So this is that. This is the King Faisal Specialist Hospital in Jeddah near the airport, under construction for the last 4 or 5 years, and paused. It's coming back to life. We worked on the master plan and medical plans with RTKL, but we did the actual design for the landscape and much of the sort of spatial descriptives, as well as the architecture, the character of the architecture for all buildings. So we worked out again sort of facade treatments that takes cues from some of the traditional forms within the historic city of Jeddah, but we place them in certain almost like layered plates in a very modernist manner. So we keep the presence of the plane, the presence of the materiality, and the environment very contemporary. Again, these are some of these captured spaces within the hospitals. Another medical project, King Abdullah Medical City. We finished all the work on this, but it never went forward. Again, this was done previously with DR. I was design director. So this, I'm really sorry about this. I apologize. Not good at that. Okay, so we created, in principle, within an overall ecosystem, a plan where we've reserved all development to one side to preserve the biocorridor and the flow of natural streams, the watersheds. And within that zone, we wanted to create a fully pedestrianized environment, from housing to research to administration to the primary hospitals that are coming this way. And then the architecture itself created this dialogue between conditions that are somehow solidly enclosed with certain level of pattern perforations, and the hanging sort of umbrellas along the pedestrian way. So you're continuously being in shade and create this continuum of an environment. Again, the envelope itself takes multiple realities, and depending on where it stands against the pedestrian sort of venue, and where there's shade and where's the mitigating environment or otherwise. This is the rehab part of the hospital, the rehab hospital. And in this case, all the wards, all the patient units and so on, overlook this lush enclosed garden. And again, you start framing a comfortable space, a comforting space for users and patients and so on. So again, the notion of envelope takes multiple realities above and beyond the particularly technical. This is the atrium space within the main hospital, and again, how we engage the envelope three-dimensionally to create a sense of a more comfortable environment. Even in hospital buildings, especially big ones, have extremely deep plans, extremely deep spaces. So one of the things that we worked out is creating insertions of court spaces to allow for certain entryways, for certain conditions of natural light, to continue to pierce through the big plan, the big mass of the buildings. This is one of the cafeterias on the main spine. I think maybe it shouldn't be here, but anyways, it's a three-dimensional design where the envelope becomes three-dimensional, and you bring the light in. Okay, this is another medical building in Doha, in Al Wakra, in Qatar. It's a psychiatric center, and the primary master site organization, site order, is fundamentally based on a primary captured space. Each patient's sort of wings have all these courtyards against which rooms happen and common spaces take place. Even the main admin lab reception building is also based on a courtyard condition, so that continues to mitigate. The conditions of landscape that were done were so integral to the idea of how we would have treated any aspect of the building's design. So the whole notion of how landscape integrates with the architecture, how we treat an envelope, how we treat internal space, what are the transition that takes place, is part of a continuum. Sometimes the aesthetics takes certain other forms, and this way, in this particular case, because of the the private nature of this building, we had to sort of mitigate the outlook from the outside by creating these screens and collage it with the mass condition. I'll skip through this quickly. It's a villa in Riyadh that is already built, but the idea, again, how the envelope interfaces at multiple layers to create multiple sort of integrated spaces and transitions. So there are multiple conditions of envelopes that come in one. This is a high-rise. This is a residential building in Amman, in Jordan. And one of the critical things we looked at, because in Amman the weather, I'll just take a few more minutes. One of Christmas, what should we do? All right, so this is, a building in Amman, Jordan, and the notion of habitation, because of, there's some really nice times during the year, whether in winter or spring or even in the nights of summer nights, where outdoor spaces, balconies, and so on are become critical to the quality of life, quality of the residential sort of spaces. So we created a condition that allows sort of multiplicity of presences and allows these to operate in, out, open up, close, as you might need to. So the notion of habitat and the typology, the placement of where this building happens, takes a particular notion of how we could carve it, how we could design it, how we could form it, to give it a situational sort of presence and expression. This is a project that is already under construction in Jeddah. It's an entertainment venue, but again, the envelope becomes this three-dimensional object that becomes forming as well as creating transitional zones for activities and human interaction. Last project. This is a project I worked on with HOK, Houston, St. Louis, a few years ago. This is the what is today PIF's headquarters. It was the Capital Market Authority as a client when we worked on it at the time. I was one of 3 directors on that. Roger Soto and Ripley Rasmussen out of St. Louis were as well. And in this one, I wanted to say, although this happened, like we designed this 2008, 2009, it's the center of the King Abdullah Financial District. We have worked out an exoskeleton, not only for the structure, but also for environmental layer. Because in the Henning-Larsen master plan, they had a purely glass facades, and we continued to negotiate that we want something beyond that. We don't want to keep a bare building. So, and we created an infrastructure for the exoskeleton where any of these louvers, which are glass right now, can be replaced with high performance solar panels. At the time, the technology didn't allow, but the exoskeleton technology allows it to be replaced if they decide to. And that takes us to this whole notion. This is the lower level, by the way, of the nobody sees that. But the idea of how you can start operating with certain mimicry sort of references in terms of the evolution of how we could go further in terms of facade technology. So we need to deal with material ecology. We could look at biomimicry. We could look at, in context of the fact that we need to operate in terms of a restorative habitat paradigm rather than just a purely performative one. So there are many different technologies. I won't be going so much into that. There are much research in terms of how we can create concentrations of solar facades, etc., and how we can create biosill as an eco-skin, so to speak. The skin technology itself can start being developed at a nano level to operate, in essence, as a living organism. And how we could look at biomimicry sort of principles to sort of start forming our structures and our envelopes in a manner that allows us to, it could be to optimize structural elements so that we don't necessarily use much material to carry a certain weight, or to target notions of the quality of the natural environment, or otherwise in terms of collecting energy. More critical, to my opinion, as well, is the high-tech versus low-tech sort of formulation that we're living in a world where there's so much sort of challenge in terms of at least 60–70% of humanity don't have the luxuries that we have here. So we have to think about low impact, sort of ingenious way to deal with more poorer situations, and how can we sort of facilitate working responses, dealing with climatic conditions, dealing with the notion of shelter and habitat in these places. I'm going back to this slide. That's where I started, the whole notion of empathy as humans and as in our relationship to nature, because this is really describes what our shared future would be. Our shared futures as humanities, as communities, and as part of an ecosystem that is fundamentally biological and organic. So we need to figure out a way how to create these empathic environments, these empathic designs. So in the end, we have a shared future, and we should imagine together a holistic designs where there are intersections of ecology, science, and humanities in the breadth and broadest sense. Thank you so much.
Dr. Hazem, for this beautiful display, first thing in the morning, of poetics and rhetorics of architecture, ecosystems, facades, and tectonics. And now for our next speaker, we have Marina Kindelan, Associate Director of Facades at AESG, who will be talking about decarbonizing facades, operational versus embodied, addressing carbon in facades. Please welcome her.
Good morning, everyone. First of all, thanks for Zak World of Façades for inviting me again. It's always a pleasure to be part of this conference. So today, as presented already, I'm going to talk about decarbonizing the facades and what is the comparison between operational and embodied carbon and how to address carbon in facades. My presentation today is going to be a little bit like kind of university lecture. I hope it's not too boring, but I'm hoping that everyone takes out of it, and I will be happy to discuss further later. This is a research recently done, so I would love to have some discussions after this. So, on my career across different places in the world, like Korea, UK, and the Middle East, I've been always looking and really passionate about sustainable, efficient, and resilient in facades. And this is what the research I'm going to present today is about. So today, there is one thing that I'm going to explain, and this is kind of the conclusion of the whole research, is triple glazing is not always the best performing option. And I'm going to explain today why it's not. So this research is not, I would love to get the credit, but it's not just me, it's just for a research that AESG has done, combining the different disciplines that we have. AESG, for those who doesn't know it, we're really focused on the sustainable design. And across the different disciplines, we always try to find and to push the limits of the sustainability. So, as majority of you as facade experts in the industry, you will know that facade is heavily related to fire life and safety, environmental, acoustics, sustainability, and commissioning. So what today I'm going to talk is about how the facades is like a specific scope or analysis of how the facades is combined to sustainability and commission when we are talking about building envelope commissioning. How, if you combine and analyze these three disciplines together, you can get like the best out of all. So, as I mentioned, I'm going to talk about decarbonizing the facades. But the first thing is to understand how we are in the world at the moment. So, as you can see, these are the annual global CO2 emissions by region worldwide. So, you can see this graphic is quite dramatic in the sense that in the past 100 years, the graphic is showing it. We need to do something. We need to try to design towards reducing that graphic because at the moment it just keep going up. So my question, I'm sorry, I'm going back. My question here is, what is the role of the facade in these carbon emissions? What is it? Because you are seeing this just as an envelope of the building, but how much can we reduce this graphic? What can we do? So first of all, just for everyone to understand how carbon footprint is calculated, and sorry if you already know, I just wanted to start from the basics. First of all, you need to understand what is the embodied carbon, the operational carbon, and when you add both, you will have the total carbon emissions. Embodied carbon is from the structure or extraction of the material, transportation, manufacturing, transport to site, construction the building, maintain the building, demolishing the building, and then transporting this, the waste to landfill or recycle. And then the operational carbon is the carbon emissions while the building is in use. Yeah? So mainly this is kind of how we calculate all the carbon emissions. And let's see what is the impact of the facade on it. So first of all, we will need to understand, okay, out of these global emissions, how much is going to construction as such? So we can see there is a 28% of the global emissions going for building operations. So how much your building, what is the carbon footprint of your building while operating, and 11% of the building goes to building materials and construction. So the selection of the building and when you build the building. What is the role, again, then we go back to the same question. What is the role of the facade in these 39% of the CO2 emissions? So this is based on a study that we know that out of this 11% of building materials, the 16% it goes to the facades. So yeah, it's quite significant if we are taking a look of this 11% of the global emissions. And if we are taking a look of the building operational CO2 carbon emissions, mainly, so in this one, how we calculate what is the impact of the facade. So you know, when you are operating a building, some of the energy goes to cooking appliances, electronics, lighting, etc. And some of it goes to space cooling and heating and ventilation. There is where the design, a proper design of our facade, is where we can actually reduce that percentage. Is where we have an influence to it. So here, based on, it's slightly different because it depends on the building. That amount of carbon footprint in terms of the space cooling and heating varies, but it's around a 34%. Sorry. So, as a number, just to give you an idea of what is the impact of the facade. If we design properly, then there is a way that we can reduce an 11, not a total, but we can influence on an 11%, 11.2% of the total global CO2 emissions, because we have 9.5 from building operations and 1.7 from building materials and construction. So again, it's a really, really big number. So we really need to make sure that we are designing properly our facades and taking both things in account, operational and embodied carbon. So if we analyze the proportion of the embodied carbon and operational, because as I mentioned, when you are calculating the overall carbon footprint, you need to compare embodied and operational. I mean, you need to add them. So what is the proportion? Currently, we are like, it's around, if you take all the buildings in general, it's around 40% goes to embodied and 60% goes to operational carbon. But we all know that the whole market is pushing for two things. Mainly, one is to reduce the energy, like the whole market is moving to net zero energy buildings. So mainly the operational carbon will reduce to the minimum. And we are also trying to reduce the fossil fuel on the grid, so going for more renewable energy. That means that in 10 years, 20 years, our operational carbon will be reduced to the minimum. A majority of the carbon footprint of the building, it will come from the embodied carbon. So the main thing is, like, I think while the market is doing really great, trying to reduce as much as possible the operational carbon, we shouldn't be forgetting the importance of the operational carbon. And the whole research I'm going to prove today is that sometimes, because we over-specify, because we are trying to reduce the operational carbon, sometimes that has a bigger impact on the embodied carbon. So yeah, this is mainly everything. To design properly, we don't need to, the best solution is not always the one that performs better as such. So for example, if we are talking a U value, the lowest U value is not always the best solution. The solution needs to be customized for exactly the project, the location, the energy from the grid. There is so many different parameters that needs to be considered. So there is no a right or wrong solution that needs to be analyzed for that specific project. So the case study. Again, this is gonna look like a little bit as a university lecture, sorry for that. So mainly, this is a case study that we have done. And then mainly there's some fixed parameters. So we have a project we took as an example to study it. The location is fixed, so the weather and climatic conditions are fixed. Then we have the type of building and the design of the building and the use. It still is a fixed parameter. And then we have some variable parameters. And the variable parameters are the facade thermal performance and the available renewable energy in the grid. And you will see that is one of the major impacts in the whole study. So the aim of this case study is to understand the relation between embodied carbon, and operational carbon in facades to find an optimal solution. This is the case study. So the case study is a project in the Red Sea, in Saudi Arabia. The use is residential. I have chosen this design because it's actually a design that really reflects the architecture nature for that location. Actually, the window wall ratio for that location in Saudi Arabia is quite recommended. It's following the recommendation because it doesn't have an excessive amount of fenestration element. So this is the case study that we base. And then the variable parameters are opaque facade options. So we went from the one recommended the minimum recommendation based on the code, on the Saudi building code, and then we drop it until 0.16. That is, based on other research we have done, the minimum we will recommend, because below that point, it starts to become not efficient or really difficult to achieve. So that are the options. We study in opaque facades, and on fenestrations, we study the same. We started with the base case from the Saudi building code, and then we reduce it up to what will require triple glazing. Yep. These are the two variables of the performance of the facade. And then we have the available renewable energy in the wall, like in the grid. So we are assuming first scenario will be 0% of renewable energy on the grid, 25% of renewable energy, 50 and 75. That change on the grid is because it's not the same to design a building, of course for climatic reasons, but it's not the same to design a building in Saudi Arabia that to design it in the north of Europe. Not just for the climatic reasons that we all know that is not the same. It's also because the amount of energy, renewable energy that is on the grid. So it's not the same if majority of your building, of your operational carbon is coming from green energy. So it's just not the same. So we need to think about that. The whole analysis is being done through two programs. So one is the IS, and is to analyze the operational carbon, and that one takes in account how much, what is the energy, the carbon emissions on a building while on their lifespan, that we are assuming in this case 50 years, that is the normal lifespan of the building. And then we have analyzed the embodied carbon of each of the facade types to understand what is the impact of trying to reduce the operational carbon on the embodied carbon of the facade. So this is the summary of the case study. Yeah? So we have the opaque facade, we have the four analyses based on the amount of energy that is on the grid. So you know, this is 0, 25, 50, and 75. And then we have the four options we study. This is on opaque walls. We have option 1 that we will say is the worst performing in terms of U-value. The worst performing one is option 1. The best one is option 4. So as you can see, while we are moving towards more renewable energy in the grid, actually the less performing option start to be the preferable option, the most cost efficient and energy efficient option. So this is why this is why we started the whole study, because we started to feel that in some cases we are over specifying without really understanding what is the energy coming from. So for example, if we are talking about the analysis 1, the preferred option, as I say, is option 4. And the payback in terms of energy, that means, okay, let me explain. So that means, as you can see on the graphic, the orange column, it's the operational carbon, and the yellow one is the embodied carbon. As much as you want to reduce the operational carbon, the yellow column, so the embodied carbon, will increase. So on the starting point, the building already has some amount of embodied carbon when you build it. And then over past 7 years, for example, in this case, option 4 has already less embodied carbon than option 1. I have some graphics, maybe it's more clear later, that part. So mainly, as you can see, because of the payback in terms of energy, option 3 on the analysis 2, option 3 will be the preferable one. Analysis 3, option 2 will be the preferable one, and we are even taking 10 years to get the payback in terms of energy. So for the first 10 years of the life of the building, you actually have more carbon footprint because you have over-specified. And then in the last analysis, that's really clear, there is no payback, mainly. The payback, I think, if I remember correct, it was after 45 years. So it's just not worth it to do it. But these are just really ideal scenarios, because the world is moving towards adding more renewable energy in the grid. You all know, so we can't really calculate for an static case. So this fifth analysis consists in, okay, let's assume that we are in a place that we don't have any renewable energy at the moment, but in 50 years, we should be targeting 60, 70, or 75% of renewable energy. What will be happening in this case? What will be the optimal solution? That's exactly what we need to do in all the projects. We need to understand current situation and understand what is the forecast. We can't guess what is going to happen, but at least assume some forecast. So in this case, you can see there is, this is quite clear, I think, on the table. Embodied carbon, always the best performing options will have more embodied carbon. In terms of operational carbon, always the less, majority of the times, the less performing one has more embodied operational carbon. And the total, in this case, because we started from zero renewable energy, in this case, option 4 is still the preferable one. But if you see the difference between option 4 and option 3, is barely minimum. And in majority of the cases, we are not starting from zero renewable energy. We are starting from at least 10, 15. So then this graphic will change. But I like this graphic because it's always also showing you how, I think this is quite clear. We have the, can you hear me? Yeah. The total embodied carbon, it goes here up and then between the different options, but the operational goes down. And it goes down, the graphic is quite inclined because we are reducing also the amount of, no, we're increasing the renewable energy on it. So this is the graphic that I was trying to show. This is the graphic that shows us what is the payback, okay? Again, we are starting from zero renewable energy, so that means in a lot of cases that the best scenario will be the best performing. But the red line is the base case. So as you can see, I started with less embodied carbon, and the best performing one starts with a higher embodied carbon. So you can see like around, this is about 10 years time, you start to have a payback. So that's the whole point. So that is kind of like, look, these are the graphics, the comparison between 0% of renewable energy to a 75. You can see how the payback goes to the end, and it's barely minimum the amount of difference of energy. So in some cases, because of other items like cost, the of the facade that will require is just not optimal. On the fenestration is more interesting because for this specific project, I really want to explain to everyone, this study has been done for this project. In other projects, will be different. So in this project, option 1, as I mentioned, is double glazing, okay, with a minimum requirement of 2.1, if I remember. Then option 2 and 3, still double glazing, but is better performing and is through different coatings or to add in argon gas. And then option 4 will be triple glazing. So in this specific case scenario, we actually, there is no, in none of the cases, triple glazing is the preferable one. In none of the cases, because it takes over 40 years to get the payback, or even in some of the cases, there is no payback at all, and I will show you. So in this case, the best performance option is double glazing, because the material itself is the one that has the majority of the embodied carbon. And the coating, it really doesn't affect that much, unless the transport, but the coating as such doesn't affect that much to the embodied carbon. So in reality, what we would like in this case is the best performing double glazing, and that will be always the preferable option for this project. So this is the same table, but I want for the same scenario for from 0% of renewable energy to 75. And again, in this case, if you can see, is minimum the difference between the option 3 and option 4. In this case, it actually be recommended to use triple glazing, but in this, for cost reasons, and again, yeah, mainly for cost reasons, it will not be suitable for the project. This is again for the payback in years. The payback in years for the from 0 to 75, still there is some payback. The scale of this, if you can see the scale of this is talking about 50,000, 100, 150, 200,000. The amount of difference that you get from the payback in energy is not worth it. It's just not worth it in this case. And this table is the one that is explaining everything. I wanted to get here to explain better the glass, the triple glazing. So we have here the different options on 0% of renewable energy. Yeah, at some point we can say that maybe the triple glazing, it will reduce a little bit the carbon footprint, not much, but it will reduce it. But if we go to this table when we have 75% of renewable energy, it's really clear. The green line is triple glazing because of the amount of embodied carbon we are adding to it it will never, after 50, no, this is 25 because it's glass. After the lifespan of the glass, it will never cross lines. So that means that triple glazing, in this case, will always perform, will always have more carbon footprint in this scenario than the double glazing 2.1. So I'm not even talking with a triple silver coating. I'm talking like a really typical, simple the double glazing facade. So this is mainly what I wanted to get. I wanted to get to the point to say, it's really important the way that we design facades. It's really important that we customize the design of each of the facades. The performance, we know that there is a code that we need to follow always as a minimum code. We know that there is always some MEP requirements, sustainability requirements, but we really need to collaborate and go a step ahead to understand that this is the optimal solution. We need to stop thinking just about the operational and include it right now, the embodied carbon, because in reality, operational can be always reduced. You can improve certain things, and on the life of the building, you can always reduce the operational. But the embodied, as soon as you design and you build it, is there, is embedded, and there is no way you can reduce it. So for 50 years, you are going to have that one. So the whole point is to explain that facade matters, and it's really, really important that we don't isolate our discipline of facades, and we coordinate it with different expertise and different parts of the building and of the sustainability. That's it.
Thank you, Marina, for this quite eye-opening presentation. Triple glazing, just going for triple glazing directly does not always perhaps guarantee the best results in terms of sustainability. So that was very, very interesting. For our next speaker, we will have from Vector Foiltech, Mr. Phil Schneider, Head of Sales, who will be talking about how to create pleasant environments with lightweight building facade envelopes.
Good morning, everyone. I'm delighted to be back here in Saudi Arabia, to be back at the Zak World of Façades in Saudi Arabia. It has been 3 years since we have presented at the Zak World of Façades in Riyadh, and now, during the last 3 years, a lot of things happened in the lightweight structure industry. But I would like to go back a little bit with the visionary idea. The idea was to cover the full scope of Manhattan in New York. That was an idea that Buckminster Fuller had in the 60s, therefore 60 years ago. Why I'm saying that and why I'm showing this one here. Let that sink. That's a wasted area. Nothing is there. And our idea with our system is to create spaces in an environment. And that is our answer. A lightweight structure, lightweight solutions with ETFE. That is in Cornwall, that is in the United Kingdoms. I think the first ETFE project that really got spotted by, let's say, global spectators in the year of 2000. 35,000 square meters, Grimshaws was the architect. And since then, a lot of things happened and developed. But what you can see here is a transparent roof, a lightweight structure, a real lightweight structure, UV transparent, therefore very good for plants, but also for people. But not only the lightweight, also lights is a very important feature of our ETFE systems, or being, let's say, something where people meet, as you can see here with this concept. What I really like about this picture is you can see the dimensions of this hexagonal cushion. It's an ETFE cushion, an inflated cushion. That is one of our installers back in the day. And one hexagon, each of these ends are 8 meters. So you can see and feel how massive this is and how, or not massive, how light this is, but how big the cushion panels are. Doesn't matter. Let's improvise a little bit. On one hand, we saw the UK, and of course here in the region you have total different circumstances. Therefore, of course, the question is, what do we do in the Middle East? Probably since the last 15 years we have been active in the region, and the first big project was in Kuwait, the avenues. So what you can see here is these are different phases of our ETFE application, 75,000 square meters, big shopping mall, client is very happy, and here you can see why. So we have long span cushions, 35 meters, and it gives you, let's say, the feeling to be outside. So especially in Kuwait, but also here in Jeddah, I think at the moment, but also it's also in Riyadh, you have very hot temperatures, but the people want to go out, they want to walk around, and that's a very, 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 very good application to see. What? Okay. Now. Don't worry. No, I don't need to play the video. I think that is all fine. You saw some simpler architecture, but ETFE also has the joy that you can really do free forms. And again, something very impressive is the Forum Romano here at the Kuwait Avenues, also seeing the different light applications that we do. That's a picture that I myself took, and I think it shows you a little bit the difference. On the left hand, you see the first phase of the avenues in Kuwait. This was a glass structure built in 2011, and later on, that was the third phase of the Kuwait avenues. You can see here the difference if you walk on the avenues and see the difference of the span and the size of a panel. So usually a panel size with our system is on the width 4.50 meters, but long spanning, it doesn't matter. We can go up to 100 meters. And another good gimmick on our system is the self-cleaning. So you can compare it to your Teflon pan when you cook some eggs. You can just wash it off. And here you see, these are just recent pictures that one of our maintenance team took. You can see here the ETFE application and here the glass application. You see, especially with the dust and sand, that we can be very effective here in the region with our low maintenance on the roofs. But of course, that was Kuwait. More to come if I talk about the avenues. I think some of you maybe have been to Riyadh. You see there's a big ditch already there, a construction site. We will see some nice ETFE applications and avenues projects within the next 2 years. But going a little bit more local, of course, here in Jeddah, a very nice project that we are finished. Inshallah, it will open soon. I think next year in March, the village shopping mall development will open. And I think, Giovanni, did I see you here? Maffei's engineering was also involved. They did the structure engineering. Thanks a lot. So there's always a good collaboration between us, Vector Voltec, as design and build company for ETFE, but also including engineers, AISG, also Marina, you were very helpful, and Bart, I will talk about you a little bit later. But now we are going to the big thing here in Saudi Arabia. The King Abdullah International Gardens, it will be the biggest ETFE application in the world, hopefully starting soon. We heard about that project, I think, in 2008. It has been a long development. We started with the production in 2020. Now we are on site, and I would like to give you some of the impressions. Okay. To think a little bit, I think it's very massive. I've been to site last month, and I have to say it's really, really impressive what the people are doing there, especially during that heat. I brought this picture. That's, at the moment, the biggest ETFE project in the world. It's the Olympic Swimming Center in Beijing, 100,000 square meters. The reason why I brought that up is this slide over here. So what you can see here are the two big crescents of the King Abdullah International Gardens. And this is right now the biggest ETFE project in the world. So you can see that here in KSA we are doing a real big thing, and it will be iconic, that is for sure. Just some numbers to run, I don't want to call them out. And that was a couple of months ago, the first cushion we installed. You can see we are installing out of nets with ropes, but really fast track. And some of my colleagues who see here as well, Mo, one of the pictures that we have taken 4 weeks ago, so you can see also how fast it developed. That was taken just 1 week ago, so we can really see how fast these installations are, and how difficult also is with the logistics. To give you a little introduction into the ETFE system in order to understand the system, I would like to show this video. It's without any volume, it's fine. So we have the secondary structure. It's usually a steel structure, but can also be a wooden structure. Then our ETFE system begins, the aluminium profile, which is then installed on top of the T upstands. And after we install all our cushions, put a cap on it, and then the secret is to inflate it. To inflate the cushion, but only with 300 to 400 Pascal, therefore very low pressure. So we don't have a compressor or something, but a very tiny inflation unit just does a and that's it, how we formatitize stable it. I'd like to show you another video, because often we get asked, this is some foil and it's just filled with air. Can you walk on that? How does it work? And this video was actually taken with the BBC. That's an original cushion from the Eden project that you just saw in the beginning. Therefore, yes, you can walk on it and you can jump on it, even though I wouldn't recommend it as you get scratches, but just to give you an impression how stable the whole product is. And last but not least, often material durability is asked. That was the first ETFE project in the world. We, Vector Voltec, are the inventors, and this gentleman, who's still the owner of our family-owned company, Dr. Stefan Lehnert, installed it there. You can see he got a little bit older. He's the gray man over there. A client that is very happy, built a new ETFE roof, and also the old ETFE roof is there, 35 years later. Something very important here in the region is the solar heat gain, of course, the G value, of course, because what you've seen before with the Eden project, totally transparent, wouldn't work here in the region. Therefore, we apply a print, and a print, if you see up here, these are dots, these are silver reflecting dots. You would think, okay, how does it look? Is it really transparent? I can say, yes, this is the same, let's say, system, the same application from the outside and from the inside. We call it sunglass effect. So if you look through this roof, the eyes cannot catch the dots from a certain distance, therefore you can see through. And just to give you an example, that's the forum in Kuwait. And see, very hot, quite dense. We applied a hexagonal print, but you can still see the buildings up there. Marina, you mentioned some of the U values. That's just to give you an overview that we work with different layers. So if we have a 2-layer system that you have seen in the video, we can reach an U value up to 2.1. But if we go further with the 3-layer or 4-layer system, so we have more air chambers, in that case, we can go down to 1.0. Last but not least, sustainability. You said carbon CO2 footprint, Marina. Obviously, I'm always thinking you need less resources with lightweight structures. And of course, with our system, which has a weight or self-weight of only 5 kilos, you need much less steel structure below, much less supporting structure, and also less concrete. Therefore, of course, if you can see it, concrete is one of the biggest polluters in the world. Our CO2 footprint is very, very low. We are 100% recyclable, and we have an EPD for our system. I would like to show you some of the reference projects and giving the architects over here from you some ideas, because what you have seen previously might be, yeah, with these hexagons or barrel wall roofs. Here you see a leaning arch roof, quite interesting, or also another application for the Expo with a carbon fiber substructure, quite impressive, especially with illumination. But that's one of you or your colleagues from Dubai. Thank you again. I think this is a great success and an example of small projects. We are not only doing the big projects, but also smaller projects, 1,000 square meters, 2,000 square meters. This is an existing building, or was an existing building with restaurants, etc. And the problem was the people didn't go there because it was just too hot. Therefore, we created an enclosed space with our roof, so that you can see here. And you have suddenly an internal space where the people can consume and go the whole time. I would like to kind of finish because I heard the gong. I'm sorry, the video problems took a little bit longer. That's one project where I wanted to show the super fast track installation. So we got heard of that project in December. We got contracted with just a concept design in January this year. We did the detail design, production, shipment, and direction up to today. And if I say it's not only the ETFE system, but the whole envelope, also the steel supporting structures with 3,000 tons. And what you can see here is one picture from 1.5 months ago, how quick we reacted. Therefore, 35,000 square meters of envelope within 9 months from contract, concept design, detail design, production, delivery, and installation. Just to give you some ideas of what also ETFE can do if we talk about tent and traditional trends, that's something that we will see in future. I think I would like to close with the words that we, Vector Voltec, we are also based here in KSA, in Riyadh, but also in Dubai. If you want to contact us, architects, etc., please go ahead. And I would like to just finish with this vision. You see Buckminster Fuller, and that was one of the visions we had here for KSA. I mean, you have this vision 2030, you have the line, and we also thought about a solution of having a big dome with PV panels that can turn around depending on the sun. And I will just close with some impressions. Let that sink. Here you can see the PV panels and what kind of climate you could do and what kind of climate you could live in. You can see the PV panels are closed. On the other end, the whole building is kind of transparent. Thank you very much.
Thank you, Phil, for this wonderful display of quite the large-scale projects in the region. For our next speaker, I would like to introduce Mr. Paulo Carvalho, Commercial and Corporate Relations Director at Ephesus, who will be speaking about future-proofing your projects, A1 fire-rated weatherproofing solutions.
Good afternoon, everyone. It's a pleasure to be here again. Thank you, Ahmed. Thank you, Zak organization, for the invitation. It's always a pleasure to see my colleagues from the facade world. So, good morning, everyone. Good morning, Jeddah. So, my name is Paulo Carvalho. I'm the Commercial and Corporate Relations Director of Ephesus. And today I'll be delivering a presentation about future-proofing your projects with A1 fire-rated waterproofing solutions. So just to give an overview, Ephesus is a worldwide brand. in weatherproofing solutions. So within the mix of weatherproofing solutions, we have different systems and different categories. So we have the breather membrane technologies, we have vapor control layers, EPDM technology, and we can completely prefabricated solutions according with the specs of each project, bespoke solutions. For us, consulting, it's a very important part of our work. So we always try to understand the needs of each project, to understand the requirements of the project, and considering these requirements of the project, of the region, then we are able to understand and develop specific solutions, bespoke solutions. I think, and this is one of the subjects of my presentation, it's about fire. So I think it's important we have some kind of reflection about these events that are happening in the last years, in the last decades, in different parts of the world. So we have the Grenfell Tower, for instance, in UK. It was in 2017, Dubai Marina, 2018. Here in Jeddah, 2019, we have the same problem. In Sharjah, 2020, China, this year, Italy, last year, Saudi Arabia. So this is a problem, a big problem that happens everywhere in the world. And it happens in high buildings, smaller buildings. So it's something that really we should put our focus. And in our company, in Ephesus, we have been working in this for the last 10 years. We are working in this kind of solutions since 2011. Following these events, different governments, different regulators, they develop new rules in order to overcome this problem. For instance, I brought here some examples of regulations that I brought the Dubai regulation and the UK, but I could bring others from other European countries and even from other Middle East countries. And there is a trend. And the trend is that more and more the required solutions are fire-rated solutions, A1 or A2 or at least B. And this is a general trend. So, and there is a responsibility, and the responsibility it is for all the agents that are involved in the facade industry. So in the last years, we have been required for the different agents in the market, like architects, laboratories, universities, consultants, contractors, facade companies, regulators, demanding or requesting us to develop solutions that could fulfill and comply with the new regulations, the A1 or A2 or at least B. So in the last years, since 2011, we have been working with different partners, with our industrial partners, with consultants, with universities, and with architects in developing new solutions. And this is a continuous process. We develop, we create, first we understand the needs of the market, the needs of the customer, the regulations, then we start to develop the product, then we test the product with our partners, then we restart again, and we restart again, and we restart again. So this has been in the last decade, this has been our work. But now, and I'm proud to present this, we have the technology ready. So we have our systems that it's Ephesus Vapor FR and Ephesus Breather FR that complies completely with the regulations, worldwide regulations. So if I go more in detail, as a breather systems, we have a membrane that is A1, that is water-proofing membrane, but is permeable to the vapor. It's a system that is composed by the membrane and accessories. It has a high mechanical strength, and it is A1 as a membrane and is a A2 as a system. This is a UV resistance, and it is tested under the AN 13859, that is a testing specific for waterproofing, flexible waterproofing sheets. The other system that we have, it's the AVCL. That is a membrane that is water and moisture control layer. It's also a system that is composed by the membrane and accessories, and it's class A1 as a membrane and works as a system as a A2. This particular solution is also sustainable. So we have the Zak Gold for this membrane that complies with BREEAM, M codes, and LEED. It's also tested in the same way as the previous one over the the testing 13984, that is a testing for waterproofing membrane sheets. Just to go more in detail, as I mentioned, we were working for the last 11 years, and this is a system that is a complete system, is test approved, and is installed. So with this solution, we can apply over different kinds of substrates, aluminium, concrete, glass. We can do different kinds of connections. We can do connections with different membranes in the job site. And this gives us, allow us and a lot of flexibility to customize the solution and fulfill with the requirements. Sometimes we have big challenges in the job site. And we have, all of us are in the facade industry, and the ones that are in the job site, they know that big problems come for the small details. So for instance, when you have penetrations or brackets in our facade, if we don't have a way to guarantee that they are waterproof, then in some time, for sure, we have a problem. We carried out some studies, and the big problems, the big complaints of the customers actually are because of leaks. And the leaks usually come from the details. With our system, we can overcome this because we have everything tested as a system. Here we can see, for instance, some details. We can see pipe penetrations, we can see the brackets, and for instance, the cables. And easily we can overcome this with the system, with accessories of the system. Here we can see we tested the membranes, both systems, over the 13501, and we test we can see here we test the accessories together with the membrane. That's why we have a system that is tested and certified. This is we achieved as a membrane, as I previously mentioned, the A1, as a system A2 S1D0. Also, we test under the ISTM E84, and we achieved the A. As we can see, in the flame spread index and smoke developed index, we achieve fantastic results. This is a solution that is highly tested. We test in some of the most prestigious third-party labs worldwide, Europe, Middle East, and US. For each market that we are present, we always test locally, and so we have local tests. We have local tests for the Middle East markets, we have local tests for the European markets, for the British markets, and we have global certifications. Of course, that is always important, the practical, and that's why I bring here some of examples of projects that we have been involved with our solutions. In US, for instance, Apple headquarters, or here in the Middle East, Dubai Museum of Future, or in Spain, we have someone from Spain here, the Diagonal Tor Zero, and the BBA headquarters Madrid. I would like also to give an overview about AVCL. So in terms of AVCL membranes, it's a membrane that doesn't allow the air to flow from the outside, hot air, to the inside, cold air, because it's vapor control layer, water and moisture. It's a vapor tight diffusion closed, and in case of fire, it protects the building from smoke and toxicity. Here I brought just a simple detail. a connection detail, ceiling detail connection in a facade. That is a detail of waterproofing between the aluminum frame and the concrete. But there's a different behavior if we consider a breather or a vapor membrane. So if we have, for instance, outside 40 Celsius degrees with 60% humidity and inside 22 degrees with 40% humidity, and if we put a breather in that particular detail, we are allowing the moisture to come inside of the facade. If we are using a vapor membrane in that same situation, we are blocking the moisture to come from the outside to the inside of the facade. So when we are in the Middle East climate, the vapor membrane is the right solution for this climate, because we have hot outside, humidity, and cold inside. And this, I'm very proud to talk about this. So in our scale, because we have the knowledge that we built with our partners, and because we understand the needs of the market, and because we are working 10 years, especially in fire protection, and because we have the right partners, we are able to bring add value. And in our scale, we can say proudly that we help to save lives, because we are helping to avoid these massive fires that I gave as an example. So it's really, really enjoyable, because we have products that technical are very strong. We can completely customize our solutions. They are sustainable at the same time. And I'm proud to say that in our scale we help to save lives. So it's always important to bring case studies, and these are some projects that are ongoing or are recently finished. For instance, their waterfront in Dubai. We can see the standard detail connection where we use our Vapor FR system with our accessories. So Dubai High, we use in the podding, we apply the vapor membrane to protect the insulation and under the CPR panel. Icon City, we use the same vapor membrane. So in the Middle East, usually we use the vapor because of the what I mentioned previous, that we have hot air outside and cold air inside. This is Dubai Creek Harbor. As we can see, it's a typical detail, a connection between facade and the aluminum frame. Dubai Creek, we have exactly the same solution. Burj Al Arab, so we apply the vapor membrane, and as we can see the details, the bracket we seal with our accessories. This was one of the Expo, Pavilion Expo 2020. We use the system to guarantee the waterproof of the flashing, metal flashing under the panels. And I brought also some examples of projects in Europe. So here we did, in this King's Row, London, we did a completely envelope where you use vapor membranes, breather membranes. We used accessories for the connections between the different membranes and the different substrates. We connect the membranes with aluminum, concrete. We did overlaps in different kinds of materials. And this is another example of customization, bespoke solution. So, as I previously mentioned, usually the problems of leakage, they come from the details. So we work on the details and we work the details. So when we have the details of the project, when we work very close with the architects, with the specifiers, with the facade companies, we are able to produce completely bespoke solutions. This was a project that we did in Madrid, so we developed a particular detail for the intersections of the facade. So it was very tricky because, of course, it needs to be like elastic and it needs to have all this shape. It was another project in Paris that we did completely customize the frame, the window. So it was assembled in production, and then it was arrived to the job site. In the job site, it was really, really easy to apply. just as a resume, because I think my time is finished, sorry for that. So just as a resume, we have developed solutions that are 8.2 fire rated as a system. This system is available and is tested and is used. It has superior technical performance because sometimes, or in the past, there was an idea that, okay, it's fire rated, then we need to downgrade technical. No, it's fire rated and it's a technical superior performance. It is approved as a fire resistant. It has a lot of different local and global certifications. At the same time, it's sustainable. As I mentioned, we have the Gold certification for the system that complies with LEED and with BREEAM. We can completely customize, and we are very close to our customers, understand their needs, and a big part of our work is to understand the needs of each project, the needs of each market, and completely fulfill these requirements. So that's it. Thank you very much. It was a pleasure to be here. Thank you for your time. Thank you very much.
There is something in you, a fire, a spark of potential, a burning desire to do more, to do better, to get to the top. You are an agent of change in a world full of opportunities where everything is connected. For years, Ephesus has been helping companies all around the globe make the right move. Chase that spark of potential within them. We will eagerly get involved and be proud of what we do. Since 2011, Ephesus has been delivering to the professional grade market the very innovative and outstanding fire-rated technology. Since 2011, Ephesus, the one and only. Feel like you've made a difference, like you're on the right side of history, the side of excellence, of efficiency and sustainability. With Ephesus, you get a say in the consequences of your actions. You determine the outcome. Join us, making the difference. Ephesus, excellence in weatherproofing.
All right, thank you everybody. We're starting off this next session strong with risk reviews for facades of existing buildings with aluminium composite material with Andy Dean, Head of Specialist Services, WSP Middle East.
Hello everybody. So what I wanted to convey today sounds like the same kind of material rehashed and that we've been talking about for years now. Well, in actual fact, we have been talking about it for years. I first started talking about it in 2006. I'm head of specialists now for WSP, but I used to be head of facades, and before that I ran a testing and evaluation and certification body for facades. And it was when I moved into the fire industry with Exova Warrington Fire at the time that I put my facades knowledge and my fire knowledge together and realized we had a huge problem. And that is aluminium composite paneling. Some of the industry knew about it already, but a lot of the industry genuinely didn't know about it. So, and around 2006, I started talking at conferences like this one on the dangers of facade materials. Some facade materials, and at that time, almost all of the aluminium composite paneling that was being sold in the region was the non-fire rated type. So what I want to do today, we've evolved a little bit. In fact, I gave a presentation in January 2016, which was a month after the address fire in the UAE, which had hit headlines all around the world on New Year's Eve. Everyone was waiting for the fireworks, and they got a massive fire. Unfortunately, I'm not intending to be jovial about that. And certainly I had to change my presentation in January, because my presentation previously was, these are the dangers of these materials. And I think for the first time, everybody knew about that. So I changed my presentation. So this presentation is actually an evolution of that. One of the things that that is prevalent about this region is the rate of change we've experienced. Obviously, I give this presentation all around the region, and these are two pictures of Saudi and Jeddah. And actually, strangely, Jeddah has retained a huge amount of its authentic infrastructure and construction. But we're doing this in Jeddah, and there are still lots of relevant buildings in terms of aluminium composite paneling and the dangerous type of aluminium composite paneling. And so here we are. But definitely the rate of change has been a big factor in this. Too much rate of change means that we can't keep up often. And I think that's been one of the big reasons why we have put so many of these dangerous materials on our buildings. So let's just go through. By the way, I'm not going to go through these. You're welcome to look at the reasons on the right-hand side here. I've got a little pointer down here. You're welcome to read those if you like. This presentation will be available afterwards if you like. But this is really just to kind of explain. 2011 was one of the first kind of fires that really kind of hit the news as a facade fire, as opposed to just a fire. I think a lot of fires previously had been facade fires, but this was a real kind of genuine facade fire that engulfed the building. Tamwheel Tower in 2012 was another one that hit the headlines. The unfortunately named Torch Tower, which has had 2 fires now, one of which was during the construction of and the upgrades to the building. Again, it's not my intention to talk about whys, but obviously we talked about the downtown address building in Dubai, and that one that really hit the kind of global headlines. I remember I was actually out on New Year's Eve, and people were calling me in the UK and saying, "We've seen it on the news, is everybody okay?" Fortunately, people genuinely were. But others, you know, those fires are real headline fires, but there's been lots of others. And frankly, they get almost kind of like pushed aside these days. And in actual fact, this one down here, Almere Tower, happened this month. This is some more pictures of it. This is it in the evening when it was going. And I think you can genuinely see that was a facade fire. It was the facade materials that created that problem. So, ladies and gentlemen, the problem is that this is still happening, and we've got to do something about it. It's been happening for decades now, and we have to do something about it. And what I want to focus on is how I want to propose a way of starting that process, or if not, kind of making that process a common process, so that civil defences understand it, we all understand it, so that when one person's talking about it, we all get it. Now, the reasons for these materials burning, again, I'm not going to go into this in a great deal of detail, but the bottom line is that it's two aluminium skins, if you're lucky, 0.5 millimeters thick, and they have a core of low-density polyethylene. That's the stuff that shopping bags are made out of. In fact, a lot of these materials were hailed as being green materials originally. I remember in the early 2000s, we were selecting aluminium composite paneling because of the greenwash and the sustainability drive that was going. We were selecting them, thinking we were doing great things. Yes, I was selecting them as well, by the way. Thinking we were doing a great thing because it was all recycled material that we were using. What we didn't know is that we were creating a big problem for the future, and sustainability is not a sustainable future if we have a series of facades that can burn down. That's not sustainable. But the bottom line is that it has a polymer core, and that's our problem child, unfortunately. There are other elements, but that's the main element of it. So why I think it is worth going into a little bit more detail about why this happened. It was rapid development in a relatively immature market. Now, don't get me wrong, that immature market is probably a little bit unfair, because this was happening all around the world. You can see it everywhere. And But it was the speed at which we were doing it. And the immaturity that I'm talking about is probably more related to the codes. At the time, we genuinely didn't have mature codes, or we weren't applying them in a deeply knowledgeable way. We didn't have national standards, really, that people knew enough about. Yes, we had national standards from other countries, but when you're using another country's national standards, you often don't have a deep knowledge of it. Again, multiple regulatory references is what I'm talking about. That we genuinely didn't know. People do ask me, well, hang on a minute, Andy, you've been here since the mid-90s. You know, you're part of the problem. I get that, I am. But we genuinely didn't know at the time. And at the time, in the early 2000s, there was so much emphasis on sustainability that we were putting those kinds of materials up. Now, again, it makes me frustrated, emotional. I still see those, if you go onto websites now, I still see those materials as highly fire rated, and green. And there's usually picture of the green one. If you click on the green one, i.e. the non-fire rated one, you usually see a picture of a family in a field. It's insidious in some respects how these materials are being sold. And so we were under the influence of all of that at the time. Price focus, it was much cheaper, particularly at the time. It's not anymore. Very few actual suppliers make that kind of material anymore. So actually the price has changed, and you can now get very, very highly fire-rated materials for a great price. Program is always an issue in this part of the world. I find, you know, very, very aggressive programs, and unfortunately, I've put on there a short-term approach. It is a undeniable aspect of our society here, that we're a multicultural society. We have a culture of multiculturality, actually. But unfortunately, a lot of people feel like they're here for a few years and then they'll be gone. And as a result, there's not that buy-in, there's not that ownership of putting buildings together that are safe. I'm going to provoke a few I'm going to push a few issues today, I'm afraid, but this is, you know, until we start to deal with these issues, I think that we can't really get to the root of the problem, and we need to get rid of this short-term approach from some of the individuals in our market. Again, this is the UAE, a story of the UAE legislation. I've left it in there. I know that we have the Saudi building code here, and the Saudi building code is largely based on the American codes, and that's been the case for a long time, which is great. But I'm talking here about the region as much as anything else. There'll be people here that aren't necessarily just from Saudi and operating in Saudi. And one of the reasons for this, for where we are now, is the regulatory change and regulatory development. I'm pleased to say, I genuinely do believe that we have the right things in place now. We have the right codes in place. But what about our existing building stock? Ladies and gentlemen, we have thousands, tens of thousands of buildings in the region that are almost certainly built with non-fire rated cladding materials. And this is why we have to do something about this. Because, again, we see these things on the news, one in September, this month, a fire. And I saw pictures today. I looked at it again in the news just to kind of make sure I knew what. Pictures, families sat outside on the curb with their children. You know, we were lucky. Nobody died. No one was injured. Some minor injuries, but nobody died. But people will. And we have to do something about this. One of the problems is that with existing buildings, and by the way, this isn't limited to our region, this is the case over many regions, is that we have, once buildings are installed, it's very difficult now to create pressure to have them change. Australia's done it, actually. After the lacrosse fire, they changed, and they insisted that there was some great deal of change. But here, unfortunately, there isn't enough pressure, in my view, to enforce change. So what do we have to do generally is risk mitigation and risk assessment. So here's my proposal on how to do it. So the first thing that we need to understand is how big the problem is. So we need to quantify our existing building stock. Now, there's a good tool out there called NFPA effect. and it's very easy to use. In fact, it's got 2 stages. The first stage, you can do it in a few minutes. So you put in the factors of your building, the types of material that you think you have, and it'll give you a scoring. But I would urge you to use that tool as a prioritization tool. If you've got a large building stock, and there are plenty of organizations that have thousands of buildings in their stock, what they need to know is what to address first. So I think the NFPA effect is a great tool for understanding the priority of your stock. And that could be done on a national level, or it could be done on a developer level. But that's the key of NFPA effect. But usually on a building, you have to go a little bit deeper than the NFPA effect to actually kind of deal with it properly. So then you have to, my suggestion is you do a risk assessment. That's obviously not particularly new thinking, but I think it's how you do the risk assessment which is important. This building here, by the way, is an existing building. I've redrawn it simplistically. We do better facade designs than that, I promise you, but we've redrawn it simplistically to convey it, but it is actually an existing building. So what we look at is several aspects of the building, key aspects of the building. Connectivity. If I was to give you a piece of paper and a lighter, you would naturally do this with it to light it. That's because you intrinsically know that lighting an edge on a vertical surface has the best chance of lighting the material. If I gave you a ream of paper, you'd probably take one piece of paper out, because you know that that's the kind of thing that gets things going quickly. Adjacency. We look at, often on buildings, there's lots of different types of facades. Some facades will burn readily, some facades will not burn readily. But what type of facade do you have next to each other, and how could one facade affect another? I'm looking at a building in the UAE at the moment. It's got a massive car park under it, and so its adjacency to that car park is a really important factor. There's not much we can do about that. The building owners are not going to stop putting cars into it. The extent is a big issue. It is a kind of slightly obvious fact that a small fire, a small amount of material will obviously create a smaller fire than a larger amount of material, but it's actually not a linear relationship, because the way that a fire works is that the heat output drives off volatile gases, and that's what actually burns. It's not the solids that burn. But it's not linear, and obviously if you have a large amount of material, your zone of effect can be 20, 30 meters, and again, you'll need to look at facade fires to see that. And operational aspects and usage of the building, and I'll come on to that in a second. So back to our particular building, particular assessment. Like I say, I'm going to kind of go through a little bit of a mock assessment, very, very simplistic, but the idea is to try and convey the process here. But before that, I want to talk about testing. In our codes in Saudi, we based the code on the NFPA and IBC, and it calls for NFPA 285 testing. NFPA 285 testing is this down here. It costs typically about 100,000 riyals to do that. You're lucky if you can get one done in 3 to 4 months, and it'll tell you if the material's kind of going to work or not. But usually, you can't wait that long, nor is the cash flow to do that. I'm looking at, again, a series of 14 buildings in the region, in another area, and we've identified potentially, bearing in mind the numbers of contractors that were on these buildings, and sorry, it's 14 zones of buildings, we've potentially identified 129 different types of metal composite paneling. There isn't the laboratories in the world to do that. And even the 129 tests that I'm going to do will cost 100,000 dirhams. I've just given away where it was, but there you go. So what I'm proposing, and this is, by the way, now is a globally available thing, is using thermographic analysis and SEM. So TGA understands the proportion of polymer. Now, if you know the proportion of polymer in the material, you can almost immediately identify whether it's a fire-rated material or not. And if you know that it's got a fire retardant in it, again, you can classify the material really, really quickly. One test on one of those types of materials typically costs 3,000 to 4,000 riyals. So it's much more affordable than the 100,000 plus all of the construction costs for the NFPA 285 testing. And again, I don't want to disregard that test. It's just not, unfortunately, practical for most buildings. Also, if you take off enough material to do an NFPA 285 test on an existing building, you're probably taking off 25 square meters of material. Most buildings won't give you that much material. The next thing I want to focus on is the actual risk assessment process itself. So this again this is an IOSH model. It's a tried and tested model for assessing risk. So what we do is we look at probability and consequence, and we rate them on a scale of 1 to 5, and the product, i.e. 1 times the other, of those gives us our risk number. And what the beauty of this is they're really straightforward, understandable, logical categories. There's nothing particularly clever in these. Might occur at some point. Large fire, significant damage, injuries resulting in doctor's appointment. High, possible. There's nothing difficult about that. Most people can rate it. Yeah, sure, there's an element of subjectivity on it, but when you do a report that you put this information into, we put these categories in transparently so that at least every stakeholder can arguably say, now, I don't agree with that assessment. I want to change that assessment. So again, very, very simple. Rate the probability, which is usually associated with ignition sources, by the way, and then rate the consequence, which again is usually associated with extent and adjacency. And you have a risk profile. Now, what that does then, it gives you a baseline risk for the building. Then you can start playing with those risks in order to bring the risk down. So if I change this, what does the risk profile do? It comes down to from a 4 to a 3, perhaps. Now, again, the best thing to do would be to take all the material off and change it all, but we can't afford to do that most of the time. Can't afford the time. Some buildings you would have to kick everybody out in order to do that. That's just not viable. So it's about reducing the existing risk to a lower level, to the appetite that you can afford, and maybe even the cost that you can afford. That's the key to this. So ultimately, then what you end up with, again, this is an actual table, snip from a table that we've done. You end up with a series of cladding areas with a series of risks. Now, the first thing I would say is, no matter what happens, shore up your existing fire safety strategy. Every building has a fire safety strategy. This one definitely. Your home does as well. If it doesn't, it should. But look, make sure that things that are already there are working. Your fire doors are not jammed. The fire exits are clear. The machinery, the fire suppression systems are working properly. The alarms are just not getting ignored because there's false alarms all the time. Get that done first. That's easy. That's going to cost you nothing. But then, like I say, there's lots of then options to mitigate the risk. You could fully remove all of the cladding, probably not likely, but you might be able to create fire breaks by taking out areas of cladding. I'm going to show you, again, a kind of very simplistic example of that. Changing the lighting types from the old halogen lights. It was a halogen light that started the fire on the address to LEDs. But you can also introduce what are called AFDDs into the system. We do that, and we've just done that on one of our projects. Arc fault detection devices. So as opposed to an ELCB, which just cuts out when there's an excess of current, these little devices, which is pretty much the same size as ELCBs, will slot into your distribution boards. They monitor the electric currents for sparks and will shut down if there's a spark, so therefore stopping electrical fire. And electrical fire is the most common cause of fire in the world, all around the world. Additional fire suppression, possibly. And again, all in the context of the fire safety strategy. So very, very quickly, what I want to do now, because I've only got a few minutes left, is I want to go through a very, very simple example. So the first thing when I look at this building, and again, it is an existing building, redrawn simplistically on a plane, is I note that there's verticality here, okay? So the first thing I want to do is take out that verticality. So I look at possibly changing that material, okay? So that would be my first thing to do. But you'll notice that the way that this has been installed here, this verticality here, is different from the verticality here. Over here, the columns go all the way up. Maybe they stand out from the building here. whereas here, maybe they're flush. So I'm actually also, I'd be worried about that, because a fire in this material could leapfrog onto the other material. So I'm going to take that out and make those all, I'm going to completely break that vertical continuity. Now, there's another zone that I call the people zone. And when I say people, I don't just mean people walking around. I mean other things that people do. Undoubtedly, most hazards become a hazard when people interact with them, actually. And that's, again, one of the fundamental elements of IOSH. So this zone, it's a 6 meter zone, is a good nominal number in your head to try and remove as much risk as possible. It's where people are, it's where trees are. It's, by the way, the zone of effect of a normal car fire, 6 to 7 meters. So I would always take that out as well. However, it's worth noting that there is a code compliance zone where actually you don't need to have a fire rated material up to a certain level. So again, we need to balance this a little bit. Remember, this is a series of preferences. So I might just leave those ones in place. Now, what you might notice about this building is that some of these cladding spandrel panels are quite tight together. When I create a fire barrier by removing material and replacing it with better material, I like to use 3 to 4 meters as that separation. There'll be people here, people around the world who'll tell you it's a meter. Honestly, the fire studies that we've done don't demonstrate that. Usually it's about a 3 meter amount of aluminium composite paneling that you need to take to make it stop, to actually break it vertically. And again, by the way, if you've got a large amount of material, that 3 meters is significantly higher, maybe 7, maybe even 20 meters. So what I'm going to do is I'm going to take away that material there. Again, so what now I've got is, if there's a fire in this office here, and it kind of impinges on the material above, it's not going to leapfrog up the building and break in other parts of the building. Now, and then what I do is I look at other aspects. Now, in this particular building here, this is a penthouse. And nobody likes a fire right at the top of the building, you know. So this is a kind of a preference thing. It's a high stakes part of the building. So I'm going to change that as well. So that would be what I would be left with. So everything you see in orange there is what I would change to bring down the risk, not eradicate the risk, bring down the risk on this building. So that's partial replacement, without talking about anything about ignition. Now, there's another thing that, again, it's really, really important. This, and if we don't consider this, we'll properly stumble, I promise you. And that is architectural sympathy. If you have a large amount of material, on this building, you can see, this isn't the case on this building, but on this building, you can see it's all columns and spandrels, and relatively easy to separate up like that. But if you have large amounts of material, like this, if you start taking out individual panels, you'll almost certainly see it. You're not just dealing with color matching, which is extremely difficult after a few years. You're also dealing with gloss matching as well. Gloss will change whether it's high up on the building, whether it's on one side of the building. It's almost impossible to mitigate for. So, you know, I would ask you, kind of, would you be happy with that if that area was an important area? Probably not. Very visual. So again, I would change all of that. So ultimately, what you're left with is your original risk profile for each of your types of your materials, and then your residual risk. And this is what we do when we present that. We then present that to the stakeholders. Don't try and read it. It's not intended to be read, I promise you. But we present that to the stakeholders, which might be insurance companies, client, might be the local civil defense. It could be tenants, it could be tenant organizations, it could be management organizations as well. And we say, these are your options. And it's the stakeholders that have to select that option. Obviously, unless it's take everything off, it's the stakeholders that have to, and that's a really important part of this as well, because it's the stakeholders' risk appetite that we're dealing with here. So again, last slide. Sorry, please don't gong me. I'm nearly finished. Just some really important points to remember. Please, when we're doing this, we've got to make it realistic, commercially realistic. if you can't afford to do it, it won't get done, and we'll end up with a building which remains unsafe. Again, the target is to bring down the risk, but it might not be commercially realistic to eradicate the risk altogether. And then again, this is manageable risk. Different organizations will have different appetites for managing risk. One of the things about this process, I think you'll agree, is it's very visual, very easy to understand, very transparent. I'll tell you what category I've got it and why I've given it a category. So, and you can disagree with me. This is your report, right, Mr. Stakeholder, and you can kind of adjust this as you see fit. Very important to discuss it with the authorities. Have that dialogue early with the authorities so that they can see what you're doing. In my experience, most authorities have welcomed some risk reduction because obviously they're the ones who've got to go into the fire. You make some contingency, put some contingency in your budget. These buildings are existing buildings. I've taken cladding off and there's been very little framing and panels have almost been nailed on. And then we had to kind of redo the entire framing. So make sure there's some contingency available. I've talked about color matching. That's always a big issue. Don't subject yourself to color matching risks because I promise you'll almost always fail. It's a collaborative process. Everyone has to be on board with this. Like I say, this is about stakeholders presenting to stakeholders. And like I said, the last thing is that the ownership stays with those stakeholders and the risk owners. Thank you very much. Thanks for indulging me on a few more minutes.
Thank you, Andy, for this highly informative presentation that concerns all the stakeholders of a building project. I would like to welcome on stage from Seal, Middle East and Seal Cover, Mr. Oliver Rohde and Mr. Thomas Toepfer.
Thank you very much. Can you hear me? Yeah. Thank you very much. Always a pleasure being here. Thank you. So, Seele will talk today about complex facade solutions in challenging climatic conditions. First of all, this is Thomas here today and myself. I'm the managing director of Seele here in the Middle East. Glass as a structural element is the first part, then meeting building performances and ETFE as an alternative to glass. First of all, what is Seele? It's always a question. Are you a glass manufacturer? Are you a facade company? We are a group of companies. Seele is the project company where we execute projects worldwide related to complex facade and roof structures. On the other side, we have Sabbagh, where we have our glass production, glass manufacturing of glass panels up to 20-meter length, flat glass, 3.50 meter maximum width. Sunglass is our production facility in Italy, where we do curved glass. Curved means any kind of curved glass, cylindrical curved, conical curved, three-dimensional bend. There's different bending processes, but this is what we do in sunglass in Italy. And then we have iconic skin, to what we come later. We are at home at any kind of steel and glass structures, membrane structures, unitized facades, and where we are very known for are our all-glass designs. And this is where I will start with the first project. First, some basic clarification or recaps for most of all. When we as Sabbagh buy the glass, it's annealed glass, and this is what we process. We process this glass to fully tempered glass, fully tempered heat-soaked glass, heat-strengthened glass, and out of this processed glass, we produce insulated glass units. We can produce insulated glass units. The difference between fully tempered glass and heat-strengthened glass, also just as a recap, is the cooling process. To break it down, yeah, the cooling process. Fully tempered glass will be cooled down very fast and therefore has a high surface tension and is used as a single layer glass, mainly when I want to reduce weight, for instance, for pivot doors, for any kind of doors. It's ideal to use fully tempered glass because it's the highest strength. Heat-strengthened glass is what we use for safety glass. It has a residual strength after breaking, and these, you see the breakage pattern, has an interlocking function. And this is why we use it for balustrades or glass in high buildings to protect from falling down, or overhead installations. This is our first project where we see glass as a structural element, and this was built by Seele the last time in 2019. Why I'm saying the last time? We built the same glass cube 3 times. The first time we built it in 2006, and we used 18 glass panels per site. The evolution after 5 years, we were able to produce much bigger glasses, and in 2011 we installed the same design and installed the same glass cube with only 3 glass panels per site and a total of 8 glass fans. The last time in 2019, the height is 10.30 meters in this case. Yeah. The last time we installed it in 2019. The purpose of disassembling and reinstalling was this, and this is also a masterpiece of structural glazing, which is the staircase we brought inside, and we had to reinstall the entire store. So this is how the evolution we drive together with the architects, we drive the evolution of glass. This sample is my personal favorite. It is a glass bridge in Austria. For those of you who are going skiing, you can visit this. It's a sport equipment supplier, and there's a bar at the top from which you can enter this bridge. The bridge is 11 meter cantilevered out of the building and is hanging at just these 2 glass steel brackets you see left and right. The main structure is the glass panels left and right of the bridge. The glass panels left and right have 6 layers of glass to hold the entire bridge. The horizontal stability of the whole thing was very easily solved with the floor panels or floor panes and some tension rods. But the structural stability of the glass panes at the side can only be achieved if you have exactly the same load at all of these 6 bolts you see here, and exactly the same load of all of the 6 glass panels or glass layers in the glass panel. Yeah? Normally, after you or the process of treating the glass is that you first have to cut the glass, and only then you can heat strengthen the glass. That means we have to cut all the holes, we have to cut the form, and after cutting, we laminate the glass together and do the heat strengthening of the glass. And what then happens is exactly what you see here, that each glass panel is not ideally flush. Each glass panel has a different length, which has the cause that if I bring load into the bridge, the single or the first glass layer, which is closest to the bolt, can break, and automatically the full load goes only to 5 layers, 4 or less layers. That means the only way to make it structurally stable is that we have a completely flush glass panels, each layer of glass, and together with the steel bracket. How we did this is a secret of our technical department. I cannot share here, but see the diligence we are using to bring this. We can do it for you if you want. So there is much of diligence in the quality assuring process in our factory and in the design. This is the last picture of this bridge. If you stand on the bridge, you can see into the glacier behind that building. It's fantastic. Another project for structural glazing is this one in 300 meter height. On the right-hand side, you see the glass bridge, which is rather an easy piece of cake. The challenge in this project was the tower. Why was it challenging? First, I told you at the beginning, we produced glass up to 20 meter length. We could have easily produced or installed this glass tower with 1 piece of glass over the full height. But replacing an 18 meter piece of glass in 300 meter height with wind loads might be a bit tricky. Therefore, we decided to go a different way and have these tension rods, which you see here. Every 1.5 meter is a tension rod, goes from the top to the bottom. That means we always had to install 1 level of glass. We had to put a steel ring on top of that, have then tensioned the rod to the bottom of the building, and only after tensioning we could install the next level. Then we put the next ring on top of that. We had to tension the rod again and fix the bolt as much that we can lose the bolt below and the level below. And now at the end, the entire tower is held into position by these tension rods. This is the last project we finished, or one of the last projects we finished in 2022 March in Abu Dhabi, also on Apple Store, Maria Island. One is the structural glazing as such for the facade. The challenge here is that these 7-meter glass panels are fully cantilevered as well. They put in the brackets at the bottom, and over the full height, they're holding themselves with all the wind loads and stabilizing, not holding the roof, stabilizing the roof. Where we're holding the roof is the other part of the project. It is a tunnel going from the mall into the Apple store. What you see here, left and right in the middle, is grooves into the glass. Here we also had to, you see this, that's a special feature here. We had to cut the grooves into the glass. After cutting the glass, we had to laminate 2 layers at the outside and at the inside 6 layers of glass together. Now you will ask yourself, why is it 6 layers again? Here at this part, the glass is also cantilevered and is taking the full load of the roof. That means it's a full structural glazing without any other supports. Yeah. It's also a fantastic project. The effect of these grooves is that there's water around this Apple store, and there's water running around down the facade over the grooves, and it causes the effect that you go into the tunnel. And most of us probably know TV. There was a time when TV had an end, and you saw the ends at the TV. And this is exactly what you see in the tunnel through the water going over the grooves. A nice effect. Now, the question is for many architects, owners, developers, okay, nice glass structure, but how can I do this to bring it in line with my building performance criteria? All these projects we showed you are double glazed unit. We could have easily done it, Marina, in triple glazed units, but we didn't do it at this time. So we can increase the layers of the glass, or we can produce triple glazed unit to increase U value, G value, or C value. But what also brings a big effect is shading. Shading, often you see here, inside shading brings down the C value mainly, but external shading brings down the U value, G value massively. And this is what we looked at as Seele. And many architects will agree that outside shading not always looks nice, as a disturbance of the optic of the architecture, brings noise when there's wind outside. Therefore, Seele has developed this element. It's called IsoShade, where we bring the double or triple glazed unit at the inside of the element. It's a completely plug-and-play system, which you put into the facade. Then you have inside a cavity, which is completely maintenance-free. There's no pneumatic or piping system required. So this is completely maintenance-free, and on top we have a fully tempered glass panel. So the lamellas are running inside the complete glass panel. You see this? Yeah. Inside the glass panel. And is through this completely maintenance-free. This is how it looks in a built-in situation. And I think it is also a way to bring down U values, C values, and G values, and can be used at many occasions in the Middle East. With this, I would like to come an end to my presentation. Here you see some other sample projects. And we come now to Thomas with his part, which is the bottom left, the ETFE. Please, Thomas.
Yes. Oliver, thank you very much for your help. I'm on? Yes, thank you. Oliver, thank you very much for inspiring presentation about the opportunities of glass and all these different solutions. I would like to take you on a journey of lightweight alternatives, and as also part of the Seele Group family, we are acting worldwide, operating worldwide with our colleagues, finding the right solutions. And sometimes we have a small battle between each other because, yeah, the client has a choice. And what kind of choice I want to show you. You see here in the nice atrium, it is absolutely covered with ETV on the top with a roof, and also beside you have some openings, which I want to explain later on. And this point, the attractive thing here by these kind of atrium is that we have a span of nearly 28, 29 meters of one cushion, and a lot of cushion beside. And it is placed in Munich. Why I'm showing this? Because Munich is 50 kilometers in the front of the Alps. So you see the span is, the roof is completely flat. And we expect every second, third winter more than 1.5 meter of snow. And that is not an issue for us, because over the air control, we can control the cushion, and we have a good monitoring system inside and each cushion, so it works. What you also can see here, that the designer and we designed together an engineering concept, which is a very lightful, attractive, and I think a unique facade, where you can see the opening. Big openings, more than 3 meters by 3 meters, and it's absolutely attractive. Regarding to the issue that we have a double sound, something? Okay, it's okay for you? Okay, thank you, because I have something else. Okay, good. So we have here the possibility of a natural ventilation. And the people love to see what happens outside, because it's only not like lamellas you can open like this. You can really open completely. And it's attractive to see have this inside-outside vision. Another atrium I want to show you, it's in Netherlands, and standing there, and it's a connecting building between some others and in the front of the high-rise. And what you see here is just here in the, they have also add additional facade in the front. These are small metal dots. They are fixed only on one point, so they can play a little bit, and the wind is going through. And it's very close to the waterfront, so the wind and the wave, especially the wind, is playing with these metal dots, and it looks like a wave is going through that. But it's also the south facade, so we have here an additional blind in the front of the facade, and you can see it here in these images, how it looks like, that you can add additional, like an art concept, applied in the front of the EDFE, and it helps you to control the U and G value, what Oliver's mentioned with the class system also. And we can reach the same values if we do it with class. But I think this image from the inside is more attractive to explain you what we can do. And you can see here, it's really reduced, absolute reduce of the minimum what is going. Less is not more possible. And we have a steel construction which is going up, going over the roof and left side down, and the proportion is very huge. And one of the additional achievement was here to bring the air supply system into the construction. So you cannot see any tubes, any pipes. So we're starting directly from the ground, basement. The whole air supply system is in the basement. We have connecting to the outside, yes. But then we have an absolutely pipe system here with the ground floor. And in each vertical column, there's the inside absolute 100% tightness concept to bring the air up. And then on the top in the corner, you see the very small, thin, translucent flex pipe connecting to each cushion. So reducement, absolutely 100%, and I think a project more than it's nearly 20 years old, very attractive. And very close to the ocean of the Netherlands, the end you have an absolute high self-cleaning concept. Yes, we have more rain in Netherlands, we have more in Europe, but ETFE is one of these materials which have a very high self-cleaning concept. Yeah. I want to jump to this project because I think it's very important to show what can be done, what can be useful to have different climate zones. But the different climate zones is now inside. The achievement was here to rebuild really a Masuala rainforest inside of the building. And there was a huge development from the ETH of Zurich together with the people from Masuala, how they bring the trees, the flora, everything, and also at the end, the animals and everything inside, and they make so many testing, so many developments that it grows. And this building is more than 20 years old, and I've been there last summer, and it's so beautiful. Please, when you be there in Zurich, take a chance, go inside, and you see later on by the pictures how it looks like. But I want to explain you how lightful it could be. When I'm showing this to my class colleagues, they say, oh, Jesus, we have to expect more than 100 kilo per square meter to bring it under control. It's completely different design, completely different concept. But we can work with ETFE less than 2.5, 3 kilo per square meter. So the main beams, the structure between them is very lightful. So we can use one span going from left to right. And here we have developed a concept with cushions with a length of nearly 110 meter, 106 exactly. There are some openings between we have to use for the smoke system and for air connections. But you see also what we have done here is a concept in the front facade, and here the same. So we can use with cushions working from the ground to the top, different design, and that's it. And this wing is just a small thing from the engineers is coming. This wing is a windbreaker, that the wind is coming over the roof and goes more up, so the cushions are not so under pressure. But that was only, let me say, a small design and a concept. Here you can see the whole span, you can see imagine how it looks like, and only some small openings, and between the openings the cushions are going from left to right. And the other ones, they are connected to each other. Not only big things are attractive, also small things. It depends on the design, and I think we have now here an auditorium. You can see it, and you can imagine what is behind this project. It's a hexagon concept we have seen from our partners, not partners, yes, competitors, a big hexagon concept from the Eden Garden. This is a small one. But attractive is here to have these hexagons from the suspended roof, starting here with a tree concept of steel, going over to the right side, and then it fixed on a concrete wall. That's it. But I didn't have seen one of these vacuum stations before. And it's, I think, one of these attractive vacuum stations. You like to be there and clean up your car and everything. But here he wants, the owner of these vacuum station, he wants to play with the colors, and he wants to play with the illumination. And it's very close to the Rhine River, very close to the French border. So when they have their national holiday, he's playing with the tricolore. So a lot of things are possible, and especially of illumination. I think in your region, and also what is coming more and more, to make an attractive entrance in a big building, and these kind of canopies, what you can see here, for example, is lying like also like a tree concept of only 4 or 5 columns, and on that you have completely unique cushions. No cushion is the same as the other one. So then we designed it with the architects together, a steel concept, and coming from the columns, going up, going over, and then also the complete construction, the complete water management. We connect the water completely, is going up over the pipes of the steel construction. And here also on the last 50 centimeters, there's the connecting for the air supply with the flex tubes. And I think just passing by, it's also can be a very attractive entrance area, and yeah, you can scale it wherever you want and whatever you want to show. Yeah? And on the right side, you see also some ideas how we can control the maintenance, how we can integrate the maintenance level so that you can walk on it very easily, and then you can clean it up, or you can look after something, whatever you need for. I think it's more an art project, but also we can put it on the side with canopies. That is the cloud. The art designer wants to have something very lightful, very flying in the air. That was his design behind. And in Brno, they have coming more and more these kind of art concepts in the city. And his idea was that the cloud is flying between the buildings. Now, we have on one side the gallery, on the other side that's an official building, and this cloud was only placed on 6 columns. very thin, very lightful, that's it. And you see here the columns, that's not more than my arms. And these 6 columns has to be penetrated between the construction and only fixed beside for blowing up, flying up, and that was a main thing to fix it, but it was completely stand. One thing is also very interesting, you see in the middle pictures, the opening, 4 diameter opening for the maintaining, because inside is a complete construction, inside you have the lighting, and inside you have the sound system, so it works. So I think I come to the point at the end. I want to thank you very much for your attention. And with this kind of images, please feel free. We are later on for any question there. Thank you very much.
Thank you very much, Thomas and Oliver, for this great presentation. Our next speaker will be speaking on innovation as continuation of the past. Please welcome on stage Mr. Jamil Adra, Managing Director of OBM International.
Good morning, gentlemen. It's a pleasure to be here today to talk with you about the favorite subject for the designers, which is innovation. My expertise in this subject evolves from an 85-year-old design philosophy surrounding innovation, resting upon a continuum so that it may celebrate tradition and its enduring aspects while never sacrificing critical elements of tradition in architectural design. Instead, design that deliberately seeks to enhance, evolve, and celebrate traditional concepts in contemporary expression, transforming elements through modern materials and systems. We infuse each project with a sense of place to elevate the art of living. Whether hospitality, master plan, community, residential or mixed-use development, OBMI's projects are celebrated for their striking beauty, arresting form, financial sensitivity, and technical diligence. Our 8 decades of experience in our practice gives us the unique ability to offer our clients innovative and original design solutions. With every project we undertake, it is our ambition to deliver wholly unique and original experience. Hospitality has been around for 1,000 years, and it will continue to be around for another 1,000 years. As such, it's a great sector for us as architects to understand the reasonings behind innovations over time, what has remained, what has changed, and why these decisions were made. I'm excited to share with you today some of repositioning and renovation projects where OBMI was privileged to take part in applying design innovation as a continuation of the past. OBMI founded Bermuda style, applying it to residences, theaters, banks, and mixed-use spaces. The limestone roofs are designed to slow, direct, and capture rainwater in underground systems. The roofs are also resistant to hurricanes, and many old buildings retain their original roofs. The stepped white roof is quintessentially Bermuda, a signature aesthetic for the destination. The design is still in use today and adapted and as needed, whether by proportion or typology. To be used in development and private residences across Bermuda to uphold tradition and continue innovation moving into the future. Challenges. Looking to reaffirm its legacy as the Caribbean leading luxury resort, Rosewood Little Dix Bay enlisted OBMI as lead architect for its most sustainable and resort-wide upgrade since opening 50 years ago. The comprehensive multi-million-dollar renovation will include the complete redesign of the resort guest rooms and suites, its 3 restaurants, and overall enhancement to the resort's garden and landscaping. As one of the most iconic resorts in the British Virgin Islands, Rosewood requested the redesign to be sensitive to the original Rockefeller appearance with the new world amenities. Retaining the resort's original emphasis on celebrating the surrounding natural environment while introducing new elements that speak to the desires of today's ultra-luxury travelers. The original structures selected in the 1960s were chosen to blend into the landscape using local and natural stones and wood. Some of the unexpected challenges, these materials and architectural design endured for over 50 years before owners determined time for reimagining of the resort. While resiliency was in mind, the resort had only anticipated minor renovations to interiors. Once Hurricane Irma devastated the island in 2017, Rosewood Little Dix Bay hired OBMI to ensure the structure were value engineered and prepared to withstand storm conditions that had flattened the island during time of Irma. The solution, inspired by the playful era in which the resort was built, the design celebrates the energy of 1960s in a contemporary, eco-friendly manner with the footprint and structures of the property remaining the same. The new design incorporates modern style while staying true to the property's prolific roots as a leading example of ecotourism. And as we enter a new chapter in climate change, the resorts reimagine. Sorry. Okay. And as we enter a new chapter in climate change, the resorts reimagined design required renewed innovation in regards to resiliency in architectural and engineering advancements such as hurricane-proof windows and hurricane-minded constructions are fortified with international code compliance. Talking about some projects in the region, in the kingdom, we are talking about the historical palaces that we are at the moment into redevelopment. The challenges was commissioned to identify uninhabited and underutilized palaces, which may be repurposed as boutique hotels under a new boutique hotel brand. Immersing ourselves in the history of the palaces, OBMI designers undertook site visits and led workshops with consultant team to all sites to understand each palace's unique value and potential programming opportunity. You may have seen recent news for a few of these palaces to receive a new story, breathing new life into properties. We are talking about the Red Palace in Riyadh, or Tuwek Palace in Riyadh as well, and the Hamra Palace in Jeddah. For Al-Hamra Palace, extravagant gardens, social clubs, fine art galleries, specialties, restaurants and dining, grand event venues and enriching culture centers are some of the unique elements presented to reimagining the historic sites. Looking at King Faisal Al-Hamra Palace through a closer perspective, we investigated in more details attribute of the site, building's history and modern day amenities that would serve to preserve the history while enhancing the experience for today's traveler. Originally, the palace was built in the 1950s and was the most prominent hospitality structure where international public figures and VIPs guests were received. So, understanding the existing palace from from the beginning, the design of the repositioned palace was to once again deliver the royal guest journey of its past. A unique and memorable porte cochere was designed as striking visual focus, providing a cultural showcase for the finest craftsmanship of the country with the beautiful proportions and intricate details. All around, beautiful gardens and landscape tie the hotel together. Surrounding the palace, the royal villas are a respectful scale to ensure the original palace remains the regent piece. Moving to Riyadh in Daraiya Gate, historic Daraiya is one of the Saudi Arabia's most significant heritage sites with roots in the 1400s, known for its traditional mud brick architecture. Settlement of the area dates back as far as the time of the Prophet Muhammad ﷺ, although the city itself came to prominence during the 15th century. It remained a significant location in the Arabian Peninsula until internal fighting within the Ottoman Empire led to its destruction and abandonment in 1880. As a result, historic Daraiya was left to decay, becoming in effect a standing ruin having only nostalgic and memory values. Challenges transform the preserve and celebrate Daraiya into one of the world's greatest destinations, a gathering place for the entire world, and one which will become a source of even greater pride for all Saudis. This will be achieved through preserving Al Turayf, the UNESCO World Heritage Site, and the unique nature of Wadi Hanifa, and revive them as a must-see attraction. Transform the Daraiya Gate area and the surrounding Wadi Safar and Al Bujeri into vibrant destinations renowned for world-class hospitality, cultural delight, and wonderful places to relax and shop. The legacy is honored with distinctive design and a banquet of luxurious experiences. To honor the rich history of the site, a sense of place is created by crafting a multi-sensory tapestry that immerses visitors in a world of refined culture and detailed craftsmanship. As one of the oldest forms of architecture in Saudi Arabia, Najdi architecture is simple and compact, developed using traditional mud and cut stone. The design innovation honors tradition with low-rise, solid masses with narrow alleyways and courtyards closed to the outside world, with the exceptions of ventilation holes in the form of geometric shapes, sometimes featuring minor decorative carving around the doorways and window shutters. To elevate for today's user, the vision and distinct approach would honor local vernacular design while infusing modern luxuries and unexpected adaptation that enhance the architectural vernacular for a contemporary audience to allow the past to guide us into a realm of bright new possibilities. The typical expression of architecture in the region is reflective or inward focused, centered around courtyards that allow for privacy and quiet self-reflection. Guests may enjoy serene moments amidst ornate, peaceful courtyards, or wander from their nudge to experience the curated walkways and artful lookouts above the wadi that stretches before them. Okay. Our last project, this is in Tazi Palace in Tanger in Morocco. It's originally built by one of the king's advisors in the 1940s, but then abandoned. Tazi Palace was awaiting a magic design spell to awaken it from sleep. This was for us an opportunity to exploit our design imaginations and create something that would inspire new visitors to Tanger as a destination and simultaneously celebrate the rich history and culture of Morocco. Innovation is the catalyst for excellence. So a site including an existing historical palace, a steep terrain, and awkward arrival formed an opportunity to deliver innovative design solutions to something potentially difficult. The palace itself was neglected, unloved, pushed against the boundaries of the site. It was, however, set on the crest of a hill, so our design lent itself to a tiered approach, maximizing the views out of the city and Mediterranean Sea, while complementing and preserving the existing structure. In order to preserve and enhance the palace as a central public element, we created the new hotel extension in harmony with the natural slope of the land and environment. The guest arrival journey had no choice but to come from the site, so our tiered design approach solved the parking underneath and provided an elegant solution for a small space. It was essential for us to preserve and repurpose the existing building, not only to show care, but also to not lose the essence of what was. The architectural style will be a clean, contemporary take on Moroccan identity that offers a luxurious and intimate feeling. Through this approach and emphasis, we created an artistic blending of the old with the new focused on the exterior spaces and common areas of the reimagined property. The result is a 5-star destination opening late 2022 that will put the enchanting city of Tanger back on the map, showcasing Moroccan cultural and hospitality. With the proper research and design approach, historic properties can easily be transformed into lovely getaway destinations that hotel guests from around the world can enjoy for generations to come. Developers and preservationists of historic architecture love the challenge of bringing beautiful old relics back to life. I really appreciate the opportunity to briefly share these thoughts with you, and I wish you all the very best of luck with your future project. Thank you so much.
Thank you, Jamil, for these beautiful closing thoughts. And now we have a presentation from Schuko, Mr. Thomas Fruhmann, Pre-Construction Services for Building Envelopes, PCS. Please welcome him on stage. Thomas.
Yes, welcome. Oh, it's loud. My aim today is I don't want to hear the bell of this gentleman, so I'm going to be quite quick, I hope so, and I hope you enjoy it as well as I enjoyed putting up the presentation. So, jumping into it. What I'm going to explain to you today is Schuko, a very brief overview about the company. Most probably of you will know the company as well already. PCS, it was mentioned, pre-construction service. What is that service about in the context of Schuko? Then I'm going to present you a product, our grid-to-shell product, and I'm going to loop the PCS to that product so that you can see how we applied the PCS, the pre-construction service, in the context of a particular product, and I'm sure you're going to like that product. If you only like it 10% of my liking, then you are amazed anyway. So, and then pictures, and references. Now, Schuko, 70 years in that field. Actually, not only the trailblazer, but the founder of the industry. Our founder, Mr. Schürmann, where the name stems from, Schürmann, Schuko, Schürmann and Company, was actually the person who set up, who had this mind and said, okay, I need to have a different approach to windows, doors, facades. I want to have it systematically, so a system approach was born. What do we do? What do we offer as a company? We do offer products, very comprehensive product portfolio. We do have products for the building skin. Building skin is basically the vertical parts of a building, doors, windows, facade solutions. There we have stick, curtain wall, you name it, we have it. The materials we have in that particular area is, we work in aluminum, steel, but we also do have fabric and UPVC. Probably UPVC and fabric is not so known, but we do have quite a big range. Now, going from the skin to the envelope, is the products that we can apply on roofs, skylights, domes, whatever. So in that product portfolio, we work with aluminum and steel as materials. We are in safety and security. Safety as of smoke sealing, fire-rated products. We do have glass balustrades. Why they are in the safety? Because glass balustrades primarily are there for keeping people not falling from heights. And in the glass balustrades also we have tested up to the highest standards recently 3 kilonewton line load, which actually means that you can use that balustrade in all applications, even where you have crowd loads. We do have security, burglar, bulletproofed, blast resistant, and we do have combinations thereof. There is a specialized affiliation company, Seltzer, 100% owned by Schüco, who does actually combinations, blast and fire and so on. So, and it goes up to very high specification. So there where the Schüco range basically stops, Seltzer will start with very high security. PCS. Now, what is that about, and why does Schüco offer it as a service to architects, specifiers, facade consultants? Our aim is, we know we have a very good product. And if you would ask me in private, I would say it's the best. But publicly, I say we have a very good product. Why does Schüco give this service? Because we want you, we want architects, we want engineers, we want clients to actually be in a position to take informed decisions. Now, how do we do that? First, the process would be we listen to the needs, we listen to the clients, we try to understand what the intent is, the intent of the design, the intent of the project, whatever the intent is. Then we see where has the project already reached in the design phase, because pre-construction service is a service that we do at the early stages before it's getting built. And then when we have listened, when we have connected, when we understand, when we see where the project actually has been reached, then we provide solutions from our product portfolio. Because what we don't want to do, or what we don't want to have, is 2 people talking about the same thing, yet not the same thing. There I put in a slide where somebody asked for a 600 Pascal sliding door, weather tight, and the sales guy says, yes, we have. But the architect wants to have it like a panoramic flush threshold, and the other person says, has it with a threshold. So this is what we don't want to do. We want to understand what are the needs. Now, how do we apply that on particular projects? That is a project that we worked on, and you see on the bottom there is this entrance feature. It was called Scoop. The architect, what he wanted to have is he wanted to have an iconic entrance. He wanted to have it modular. His only understanding of modular was unitized curtain wall. He wanted to have obviously a smooth transition from one panel to the next one, and he wants, obviously, like everyone, cost effectiveness. Now, what we had to do is obviously, this is how the site looked like at the time when we came already, so the site was ready. Now, what we needed to do is, or what we do is, we manage expectations, because we can have a product which is unitized, but bear in mind, if you want to do that scoop, which is 3D basically, you have 2 possibilities. Either you make it with rolled profiles, and or you do the cold bend. Cold bend will have some limitations, so rolling profiles, hot bend glass is not cost effective. If you do it with cold bend, then there's limitations in how far you can bend, which means you probably would get what you see on the picture, some offsets. So it's not about if this is a bad design or not, it's just about managing expectations. And if someone has the idea of having very smooth, then probably he doesn't like to have such offsets. Now, the next, let's say, evolution would be that you say, okay, we have a product, stick curtain wall. You can do it the same thing with the stick curtain wall. We have done it. However, it's not easy, not straightforward. So we get a kinked mullions. So that also would involve that you would have 2 brackets on each floor, because if it's kinked, you can't slide one mullion in the lower one. So, and it's not unitizable, it's not modular. But then we asked, what is if we had a system that is parametric, a system that is versatile, a system that is out of aluminium, which means you can recircle it into the process indefinitely, basically. What is a system, if we had a system that gives you freedom of design, is easy to fabricate, easy to install because you can pre-assemble it, and is cost effective. Now, luckily, what is if we had a system that would work from the grid lines of the architect into a structural geodesic shell? What is if we would have grid to shell? Now we do have it. Now, what does the system entails? It entails, for us, we do the design. So we do the design in a sense, not in the sense of an architect, but we design the shell. So we take any 3D form, take the shape of it, and then model the grid of it to have, let's say, the best utilization. That, because it's 3D, it's looped, it's interconnected in a series of softwares. So we have Rhino plugin, we have where we do the design, we do have a Grasshopper where we do the parametric, then the whole thing is looped into a structural software. So the moment we change something, we get out the structural verification of that. And if all that thing is done, we have a software, which is PowerMill, which gives us the CNC data for the nodes, because the product consists out of rafters and nodes, and the nodes can be individual. And at the end of the day, so we do the modeling, we do the design, the modeling, and then we generate, out of the 3D, we generate the components. Which means the beauty of the system is, as I said, it's versatile, it is very, very flexible. However, the number of components is super limited, because we have an extrusion, we have our gasket system, which is tested, and then we have the node. And the beauty of the node is that all the geometries are actually done in the nodes. So the rafters would receive a 90-degree cut, and the nodes have all the geometries. If traditionally you would like to have done something like that, you would use an add-on system in many cases. So what we have done is we have combined the steel with the add-on system into one single system, which is extruded, and then we have the nodes. The nodes, as I said, are out of the solid aluminium. They are done in a high precision 5-axis spindle milling machine. So there is, which works in the microns, on micron level. We don't need it in the building industries, but it's what the product can do. Now the nodes, if I compare the nodes, traditionally if you would have done it in steel, if I compare it now to aluminium, our node is like a star shape. I just put random steel in comparison to our node. Our node, because it's CNC milled, it always looks the same. So there is, aesthetically, it is always a very high aesthetics. And I didn't use particularly not so beautiful steel nodes, but this is just random. Whenever I see something, I just take a picture. The system has been tested. It has been tested horizontally and vertically in our testing lab in Germany. And horizontally and vertically is important because a system that works horizontally does not necessarily need to work vertically as well. So there's different aspects of it. So it is very important, if you have a facade or whatever it is, and you apply it horizontally and vertically, it has to be tested in both of the applications. Now, the system is sturdy and has been installed above 150,000 square meters already. So I keep this picture always in so that people, because some say, oh, it's aluminium, is it light, is it strong enough? Yes, during installation you can even walk on that. Now coming back to where we started this scoop. So The architect had his idea of iconic feature, modular. He wanted to have it smooth and cost-effective. So we asked him, okay, with all the things that we discussed before, you know, the offset of the unitized curtain wall, if you want to have it cold bent or not rolled, we asked him, can we propose something from our side? And he was basically happy. I said, yes, yes, please go ahead. So we proposed the design for that scoop from our side and presented to him, and this is the end result, and he was happy with that. And it's not only a concept, we have done that also in practice. Another project was when I was called to, it's a vertical application, when I was called by an architect, and she said, Thomas, I have a project, it's parametric, it's a vertical facade, it spans 2 floors, and the key is we need to have it installed or start the installation or installed 12 weeks after we have approved the design. So, and then she said, okay, we want to have stick system, but then I said, yeah, if you have stick system on a 2-story high, 2 floors, you need to have some reinforcement inside. If it is parametric, you probably can't put it inside, so we'll end up with something on the outside, or you know, a double layer. Again, we came to the same point where I said, okay, can we suggest something from our side? And we did the project then again in our grid to shell in a vertical application. So it works horizontally, it works vertically. And we have done that and installed it on several projects already as well. A third project where we asked to provide some pre-construction service was a big shopping mall. Now here the key was the client, it's an 8,000 square meter roof, and the client was keen to have the shortest installation period. Why? Because bad weather season was approaching, and he wanted to have the fit-out works during the bad weather season, so he needed to have the skylight in place. So when we came, so where we started actually was he had this design with rectangular glasses, but the design as such was more like a traditional rafter with cable tension, fish belly, and then an add-on system. So we as a company, we do have such a system. However, if you think about to install this amount of components, so you would need to come in with the steel, you would need to come in with your tension rods. You need, after then you have done, you do the alignment, you come with the add-on system. It's not about that the design is not, because for me the design, as long as design works, it's beautiful. The problem was here, the client wanted to have something that is quickly to install. So I thought, and I told him, I don't think that this can be installed quickly. So you need to have something that you can somehow modularize and pre-assemble. So again, we came up with a solution by which we produced our grid to shell with rectangular glasses to keep the design intent, because this is where we started from. And then we took the liberty to provide something where is it okay. Maybe you would like also to see something what could be done and make it smooth with triangular glasses, and we did that as well. And yes, the client liked it, and because what he didn't, the other advantage is if you do that in steel, in the way that it was intended before, you would need to have a temporary platform checked up, and from that platform you would start your installation, which means in turn all your circulation area in the ground floor would be somehow congested, and it would be very difficult for the fit-out workers, for the fit-out contractors to move. Our product, since it can be pre-assembled as aluminum, you can pre-assemble it and lift big chunks in place. So this is what we have done. So you, because there's a roof next to it, so we pre-assembled parts of 200 to 300 square meters and lifted them in place with a crane. Because it's aluminum, it's lightweight, you can do that. Only 3 minutes. So we have done that. So you see some photos where we have done it here. You see the people. So this, just take that and multiply. This is the way how you can pre-assemble and put it in place. We have done big spans. So what can we do with this grid shell product? We can do big spans. It can be a skylight. It can be, big skylights. It can be a vertical facade. It can be anything in between. So there's a project where it goes from vertical into horizontal, and you see the smooth transition inside. There's no secondary layer. It's self-supporting. And last project I want to show you is what here what runs in the background is just that you get an idea of how that can influence your design. Last project which we did is that I'm going to show, not which we did, in Dubai. The client came, he had a courtyard, open courtyard, al fresco dining outside, and he wanted to have like a steel structure with glass printed to give some shading. I came and said, why glass? Why steel? If you want to have shade, we have a product which is a fabric, and it has very well-defined shading values, so can we use that? Or I just proposed it. So what we did, we actually combined the two forces of our, in our company. We combined with our engineering department our facade system plus our G2S system and combined it in something where the G2S system can carry the facade system. And yes, in that case, it was solved, and this is the final product. Is an image of the building itself, and you can see the nice patterns. This is what the designer wanted to play with. The nice patterns on the outside, on the dining terraces, where then where the al fresco dining will be. And it was installed, as I said, it was pre-assembled. So this is what can be done. It is pre-assembled in parts. It's lifted with a tower crane, with any means of light crane, because the parts are anything, depends on what the capacity of the crane is. But if it's 2.5 tons, that is enough for 300 square meters. And it's therefore very quick to install. So yes, and it can be also a feature. This is where we applied G2S as a feature on projects. Last not least, bridges. Maybe you didn't think of, but it also can work as a bridge. The biggest bridges we have done with spans of 35 meters. Looks quite nice, I would say. So it's a very versatile product. Best is made in GCC. So it's locally made, it's locally available. Carbon footprint reduced, 5 seconds. Fully parametric, blurring the boundaries between vertical, horizontal. That's it. If you want to see the product, please visit us outside on our booth. 000, no bell.
Thank you very much. Thank you for the amazing presentation. And now for the final presentation of the session. We have Mr. Juan Martin de Leon from ROSHN. He will talk about the impact of Jeddah Vernacular Code on building designs. Please welcome him on stage.
Good morning. Assalamu alaikum, everyone. Thanks for inviting us over to this fantastic event. Today I'm not going to talk about all this super nice high-end buildings, cladding systems and facades, and not talk about U values. Neither of that's going to come today in this presentation. But I really want to talk about the work that we've been doing for the last 4 years within the kingdom, and how is that being implemented throughout the different regions and parts of the kingdom. ROSHN is a master developer for the Public Investment Fund. Our original mandate is to develop over 1 million units for 2030, big challenge. Our board is very much, and His Royal Highness is very much interested and keen to see how the local culture is being translated and is being future-proof for the next generations to come, and how is that generating that sense of place belonging, and most importantly, the legacy that needs to be translated to the new generations to come to be building the new Saudi Arabia. We've been appointed to be the 5th Giga project within all the Giga projects within the kingdom, And I'm very happy to very quickly take you through this little presentation that unfortunately I cannot reveal all the information behind this, but this is just a glimpse of what is the design process that we're taking to implement these vernacular elements within our buildings. So very quickly, when we approached this task, we had very clear what are the key elements that we need to take in consideration with building the codes. I'm referring to a code because, and due to the fact that all our projects are very rooted and are only for Saudis, they're not, this Giga project is not about attracting investors or providing housing for expatriates, but to provide affordable, no, not affordable, sorry, I shouldn't say that, because our original mandate was to create affordable housing for Saudis, but we fairly quickly developed into a proper real estate developer that also takes care about, Saudis, but at different, sort of social levels. Having said that, the key principles or pillars that we're building in our codes that reflects the Saudi culture in our buildings are mainly texture, volumes, openings, patterns, and the colors. I'm going to build a little bit on that later on in the presentation, but I want to capitalize on this matter, which is really important for us as designers and developers, on the importance of the architecture that needs to come from the city and from the scale of the city, and what are the key elements that the city is bringing and is informing the architecture per se on the formalization of the buildings. The Islamic classic organic fabrics are mainly rooted into the anti-grid kind of approach. They have they've been developed throughout the years to cope with the counter levels, to cope with temperatures, to cope with all kinds of again very localized issues or opportunities that creates those spaces. We understand that buildings cannot be independently developed in isolation, but needs to come from the context, from the fabric, from the essence of the place, right? I'm going to quickly, go through what are the key elements that defines our planning hierarchy when it comes to master planning, but what defines our streets and our buildings within the context. Saudi culture is very much is very family oriented. It has a lot of interactivity with with the different sort of levels of within the family, and open spaces are very important traditionally in Saudi cities that we are kind of forgetting when it comes to applying grids and efficiencies into master plans. We're not doing that. We're creating places for people, families, and we're trying to raise the bar on how to approach big pieces of land. Open space is critical to provide accessibility to public amenities, to make sure that we have enough space around us that we can leisure, and most importantly, to create, to have spaces for people to gather and people to share. If we take our Balad as an example, we will find a lot of design principles that if you don't really get into it, you won't be able to understand how these design drivers for the buildings and for the location, for the formalization within the right-of-ways. I'm saying this because when you walk, even if it's in summer in the Balad, and you walk in the streets, there's always a breeze coming in, right? This is because the fabric was oriented to the predominant winds, right? It's not casual, it's something that is reacting to the locality aspect of it, which is very important to understand how important is the city versus building. Okay, so not going to dwell too much about that, but when you analyze the fabric and you analyze the buildings, scale of the buildings versus the human scale, you understand that there's also a climate interaction. There is there's heat, there's dust, there's there's certain months in the year that is very, very hard to walk. So the proximity of the building is just to react to that shading. is just to provide walkable pathways to get into the buildings and to, to ensure that people will still interact when, in the months that are not so pleasant, let's say. That interaction of commercial activity in the ground floors, as you go up in the building, different stratas of or hierarchies that happens is very much interested for us. I want to talk about one element that is being out there for forever, and is the Majdubah. Is an element that has a functional meaning and has also an aesthetic meaning. On the functionality-wise, is an element that provides privacy to the inside. It's an element that provides comfort because it's shaded, it's creating shade into the building, but also is creating natural ventilation into the interior spaces. So again, it's just a reaction to the climatology and to the special condition. The other part is the static. The Majdubah is traditionally an element of status. It defines the intellectual levels, the affordability levels. It gives, it goes from the handcrafting element all the way to the aesthetics, right? So it's an element that we've been taking in consideration when we built our code as an element to just to react to that legacy, but also I think this is very important. When I'm talking about translating the legacy or the vernacular into new contemporary architecture, I'm not talking about facadism, I'm not talking about pastiche, I'm talking about extracting from the buildings whatever is relevant for whatever is giving the reasons of climate and culture, and translating to a contemporary code that is meeting the aspirations of the new generations that is coming. So the use of the Majdubah, sorry for my Arabic, it's been basically. I'm going to just briefly talk about 3 different ways of doing Majdubahs. The first one, and I'm going to talk about colors in this time, is a natural wood, is what you could find outside, and you will, depends on how much you can afford, you will just hire someone just to build that Majdubah for you. The second one is the introduction of the blue. Jeddah is traditionally a trading place where there's a lot of interactions of cultures. Throughout the years, there's a layer of a layer of a layer of different cultures that are bringing, from their places of origins, a culture that has been rooted into the country. So we can see blues, we can see some turquoises, we can see some, colors that are not specifically from the soil of where we are, from Jeddah or from the Mecca region. And then, of course, the implementation of the green, and this is not fully confirmed, but when King Abdulaziz established Saudi as a country, they introduced the green color as a sort of national flag, and that's being implemented also in these elements. This specific case, Al-Nasif House is one of the most relevant examples of Jiddawi or Hijazi architecture within the Balad here in Jeddah. And it really represents all the things that I just mentioned. It's very local. You can see on the claddings, on the facades, that the implementation of the coral stones. You can see the quality of the artisans when it comes to put together those Majdubahs. There is you can read different levels of within the stratas of the buildings that defines the high level, the intellectually but also economic power of this family. One of the other things that is very much related with the sort of the leisure of how Saudi families get together, and apologize if I'm stating something that is not fully correct, but the use of the roofs. I mean, sometimes we see all this fantastic, master plans or fabrics that are really rich, but they're not really fully activated, right? something that happens in the Balad that is significantly different on other regions, not throughout the board, but the use of the roofs traditionally is something that it really matters for the families, right? So in every house on Balad, you can see examples of how the different panel textures filter the air, but also remain the privacy in an open space. So it's not only used on interior spaces, but also on the exterior ones. So there's a few examples of how this panelization on the roofs is being applied throughout the different areas. And again, most of the houses within the Balad has a little modulis at the top of the building that provides that sense of stay outside, but at the same time being enclosed. We can just build around this for forever. These are just examples of different implementations, colors, and the interaction of the buildings with the street, which I think is really important, and how the different reacts to the different conditions from a commercial perspective, but also from as I said, stratas of social levels. This is a very neat example of one of the most beautiful, in my opinion, houses within the Balad. It belongs to a very important family, and you can see the quality of the artisans when it comes to put together these wood panels. This is just an axonometric of the same building. Public buildings are also very much rooted. I mean, I'm talking about this residential at the beginning because I think it's the core of our business, but of course, at the scale that we're working, talking about 50 square kilometers of land, we also have all kinds of public amenities, mosques, schools, and we also need to provide this coding systems for the public buildings. In this case, this is just the mosque that is at the Balad. It's a very interesting example of the utilization of the coral stone that is being applied consistently throughout the Balad, but of course, due to the resistance of the material and the durability of the material, it is not longer applied so much as it used to be, but it's certainly an identity element that we are preserving. Again, windows, patterns, textures, colors is what really makes Hijazi architecture different to other regions. It's still a very solid architecture if you compare with the Asiri province or with Salmani, but due to the commercial strategic location that is being we have a lot of very interesting elements and a lot of colors that is not so obvious in other parts of the country. Patterns that are very much related with geometrical elements, and again the interface between the house and the cities is also one of the elements that, of course, we need to take in consideration when it comes to provide or propose a vernacular approach. Unfortunately, I'm not able to show any of the contemporary examples that we've been developing due to the obvious reasons. It's not being launched yet, and His Royal Highness is not. He wants to reveal himself. Anything that we do specifically for ROSHN, as is very much Saudi rooted, and that's pretty much it. I hope I give you a little glimpse of what we understand Hijazi architecture is, and thank you very much.
We'll start right off with Mr. Bart Leclercq, Head of Studio at BSBG. He will be talking to us about the lessons learned from 3 exemplar facade projects. Bart?
It's a great pleasure to be here. Thank you so much for the invite, and it's always great to be here in Jeddah. It's so different than Riyadh. Because of some of the NDAs that we have signed over the last few years, I might not be able to really give a lot of detailed examples, but I will talk about some of the things that we've been doing over the last couple of years. So who are we? We are BSBG. We are Brewer Smith & Brewer Group. We've been here in the region since 1976. And we are a truly international company in a way that we've got our head office in Dubai with lots of international architects and lots of people from all over the world that are working for us. And from Dubai, we've ventured out into the rest of the world. We've got an office now in London where we've got probably about 15 people. And we've got now an office here in Riyadh as well, which I'm really, really proud to head here in Riyadh since about 2 years now. Now you can see here from the clients that we are working with, some very familiar faces there. And also you can see a couple of Saudi clients that are there, including DGDA and Misk Foundation. And to be honest, this slide is already out of date because we can add now 7 entertainment or Saudi entertainment ventures to that as well. So slowly this list is growing, and that's actually giving us great pleasure. Also, many of the hotel operators we've been working with in the past, as you can see here. And let's talk about some of the key roles that we do. We are really known for being a lead consultant. And that means that the client comes to us and says, we want you to do the whole thing. We want you to do the design from pre-concept design all the way through to issued for construction documentation. And we want you to supervise the work on site as well. Now, many of those disciplines we can actually do in-house. So that would be architecture, structure, and interior design. But for any of the other specialist consultancy services and landscaping, specialist lighting, all that stuff, we would go to our trusted partners that we've worked with for the last 15 or so years. So a very, very steady and good pair of hands that can take on any project in the region. So the client is only dealing with us then directly, contractually, and the rest, we take care of the whole thing. Now, we were very, very lucky. About 3 years ago, we've managed to get Mike Lewis, who used to be with Benoit for 18 years and is famous for the Ferrari World that he designed in Abu Dhabi. We managed to bring him in, and around him we've now built a really strong team of very young architects, good concept architects, and together they are being really, really successful. And one of the key reasons for their success has been that their design process is very, very much liked by the clients. Because what we do is we start right at the beginning in concept design, we start doing everything in SketchUp, 3D environment, and then as we go through concept and schematic design, we, at the end of schematic design, start turning the whole thing into a very, very detailed and fully coordinated Revit model. So what happens is that when we are having our client meetings, we are literally diving straight into the models, and we walk through it, and we have a look at the lighting, and we're having a look at the various seasons, and we're going to have a look at the structure and the textures and the colors, and they can see it all, and it's literally happening right in front of them, and it almost feels for them as if they're part of the design process. And I think that's a key reason for our success. Now, many clients in this region really like the idea of going for one of the very famous architects to do a concept design. The likes of Foster & Partners, Zaha Hadid, Studio. But obviously you don't want to hire these really expensive architects all the way for the full duration of the design. So this is where we come in then and actually take on the executive role. So we bolt on, become part of the team, we shadow the concept design and the schematic design by these really big star architects and give them advice on the local rules and regulations, materials, what can be built, what can be procured in the region. And then as we come to the end of schematic design, the whole responsibility turns over to us, and we bring one or two of the individuals from the concept architect into our design team in the office in Dubai, and they become part of the design team as we are progressing it through detailed design and construction documentation. And that's working really, really miracles. It's absolutely a success formula for us. Now, some of the projects that we've done, I'll go through that now. This is one that probably stands out. This is the ICD Brookfield. It's a tower, 53 stories high, built on a 7-level basement. Now you can imagine if Foster & Partners are doing the concept design for this, and they don't really want to get involved too much in the actual coordination and design of the basement. So they said to us, why don't you guys figure out the basement while we are working on the design of the tower itself. And that's exactly the way we did it. So while Foster & Partners were designing the tower, we were already procuring the basement and allowing the contractor to get on with it. 7 levels basement. It was at that time probably one of the biggest basements in the world. A couple of thousand car parking spaces. Now what's really impressive about this one is this building managed to get LEED Platinum. Just a few slides here. Multiplex was the contractor, 150,000 square meters of GFA, so a really big success. The building is, at the moment, obviously an office space, and 50 or 83% of the building is occupied. So it's the client is really, really happy about it. And actually looking at another site now to build another tower for exactly in the same way, because he knows that he can get really absolute premiums for a platinum building, a LEED Platinum building, and get some really good returns on it. Now, like I said, we do everything in Revit, and you can see the 3 slides all the way in the top are showing the architectural model, the structural model, and then the really, really dense and well-coordinated MEP model. So we work the whole thing out before it goes to site, so we know that the thing can be built. I decided to show these 2 bottom pictures as well, because what is really important here in the Middle East, and we've learned that the hard way, is that when you present a design to a client, they're going to keep that picture, and they're going to say, once the product is finished, they're going to say, I want to make absolutely sure that what I asked for is exactly what I'm getting. So they're looking and comparing it. On the left-hand side, you can see the computer-generated image that we have of the project. On the right-hand side is the actual image on the site now that after it was built. So you can see how great, how similar they are. A very good success. Some of the details, you can see this is drawing scale 1 to 2.5. We went through a great level of detail with the contractor, the facade contractor, Alabar, to get everything on this building really, really completely well defined. Another project we worked on is the Opus building, and this is a building that had a bit of a history. We started in 2007 for Omnial Properties on this one. Madi is the owner of Omnial Properties, and he was very, very clear. He wanted to have Zaha Hadid as the concept architect. And she came with this very, very complex double curvature atrium space. Absolutely fantastic. So we started in 2007. In 2009, there was an absolute major crash of the property sector in Dubai. So the whole project sort of first went on hold. We had already constructed quite a bit of it, so already the basement was already constructed and some of the cores for a part. And then the owner said, I really would like to change this from a full office building into something that's more mixed use. So on the bottom, I want to have a hotel, then I want to have offices, and all the way on the top floor, I want to have branded residences. So suddenly the whole function of the building was changing, and we had to make some major adjustments to the core to make sure that this was going to be possible to do this. The end result was finished sort of about 3 years ago, and you can see what the outside looks like and the inside. Very, very sophisticated, very detailed. And the big feature there is also the connection there, the bridge at the top. You can see over 3 levels, spanning literally from the concrete core to the other concrete core, a span of 38 meters in total. Very, very complex and tricky to build. And that's why it took so long. So altogether, it took us almost 10 years between the full design and the construction. Well, we're very lucky to say that we also have quite a bit of experience here in KSA. This started around 10 years ago when we did the IKEA in Dammam. And we've been very lucky at the end of 2020, we were able to secure a very, very big project, a very big school in Riyadh. And on the back of that, we decided we were going to make the jump and set up an office here. And I'm glad to say that we've got now 12 people here working in Riyadh. and becoming very, very familiar. Now, I spoke earlier about Mike Lewis and his team and presenting these really nice 3D models right at the beginning of concept design. And this is an example of a project that we're currently looking at in the center of Riyadh. It's got 16 F&B units and retail spaces. And you can already see there's an enormous amount of detail here. So the client was really, really happy and really enjoyed this full design process with us. Now, what I really liked about the presentation that I saw earlier from various people here in the audience is some of the ideas that I can almost immediately implement on these type of projects. So very, very grateful for the inspiration you guys have given me earlier on this morning. Another project we got recently involved with this one. It's confidential again. It's a headquarters. It's right next to the Wadi's Edge in Riyadh, and the concept was won by Conrad Gargat. And they realized, because of their lack of knowledge of the building, the rules and regulations here, the architectural record, things, the use of materials, they really quickly came to us and said, can you join us in our team? And that's what we've done. It's not a big building. It's only 9,600 square meters of GFA, but quite complex with a very, very large overhang, a very large cantilever, as you can see there. This is another project we're doing at the moment in Riyadh, confidential. It's a school, and we were awarded on this project in December 2020. The site is very large. It's 285,000 square meters, and the total GFA is 110,000 square meters over 22 buildings. And the request was to have this school open by the end of this year. So we literally had, for the full design, all the way up to the end of construction and finished construction, less than 2 years. And a major, major challenge. And I can tell you, we are very, very well on our way to actually get this one now completed. We do have some challenges with the contractor, who is really struggling with getting the right materials and the right people onto the site. Just a couple of little things about some of the elements in there. I want to talk about the louvers. We were very lucky. We had a fantastic consultant on board, which is AESG. That was Marina. She helped us with actually doing research on how we were going to deal with the lighting, the natural lighting inside our buildings. Now, you can imagine you want to have enough natural daylight in the school, but you want to prevent glare to happen. So we had to come up with an idea of how we're going to take the direct sunlight out and how we're going to cater for all the seasons, not only right in the middle of summer when the sun is literally at an angle of 88 degrees, but also in the middle, right in the middle of winter when the sun is actually quite horizontal. So we figured out that if we're looking at the winter or the summer situation, the sun is literally coming from right above. You need to make sure that you got enough louvers in your horizontal planes, basically. And we came up with this idea to have these louvers at an angle of 22.5 degrees, and this way that even all the way to in the middle of summer, you would not have any direct sunlight coming into your schools or into your rooms. Now we want to use the same angle on the vertical facade, to deal with the winter situation. But there, when we presented this, I guess, to the concept architects, they realized that if you're going to look at the building, you're going to see these louvers quite well. So they said, is there not some kind of way we can make these louvers horizontal? And the only way you can actually do that is actually if you make the louvers a little bit wider. And obviously that has got a cost implication. So we went back to the client and said, look, we think architecturally this will look better, but it will cost a little bit more. And the client actually thought it was a good idea, and they agreed to it. I think I'm telling the story right, huh? There you go. So this is the test that we did then. AESG made some models of it, and above you can see the situation if you don't have any louvers, And below you can see the situation when you actually use the louvers as we propose them. And what is nice about it is you can see there's a serious glare problem on the left-hand side if you don't do any louvers. And the bottom picture shows if you use the louvers, all the glare is gone basically, and it's within acceptable limits. Same thing for the natural daylight. There's enough natural daylight coming in if you don't use any louvers. But even with the louvers, the natural daylight coming in is still, at an acceptable level. So a great study, and that's actually what's being implemented at the moment. Now, this is the material that we have on the site. So you can imagine when we showed the concept architects and walked them around, and they saw this material, they thought, wow, this is just, it's beautiful in texture, it's beautiful in color, it looks quite strong. We'd be really, really silly if we're pretending to be sustainable and we're not using this material that we're going to dig out. So why don't we find a way how we can use this material? Another slide there, that's James. He's one of our architects on site. Now, we took some core samples and had a look at 4 different options basically. The masonry stone wall, the stone veneer faced precast, the Gibeon wall, and then the ventilated stone facade. Looked at all 4. This is one of them. Unfortunately, the strength of the stone was very diverse. So you have a lot of strength in the top layers, but it was quite weak at the lower layers. And there was a lot of inconsistencies in the stone as well. And that's the reason why we decided not to go for this one and not use this kind of method. This is the second one, where you've got a concrete panel basically, and you've got your stone actually on the side. But it's quite tricky for the contractor and a lot of work to do. So this was actually discarded quite quickly as well. The third one is the Gibeon wall. It's literally you build a steel cage and you fill it up with the rocks that are coming from the side. And this way you create this really nice looking sort of facade elements. And the contractor was asked to make a few mock-ups of this. And they did, but they didn't do a great job on it. I think they were not really that interested in going for one of these kind of construction methods. And they proposed a really high price, and the quality was actually poor. So we were a bit disappointed because we thought that this would have been a really great option. The fourth one is this, but again, I talked about the strength that was very variable, and also the fact that there was a lot of inconsistency in the structure of the stone. And this was not an option as a result of that. So unfortunately, we did do the study, we did try it, but we didn't get it, we didn't do it in the end. And that's a bit of a pity, I think. Wow, we've got another 1.5 minutes. I want to thank you for listening. And I hope to see you again soon with a little bit more details on some of these projects once the NDA has been lifted on them, okay? Thank you so much.
Thank you so much, Bart. Our next speaker has actually fallen ill, Giovanni. He could not travel. So we will bring on Khamis Majdubah from Saint-Gobain, Solutions Manager of Saint-Gobain, to talk to us about meeting the demand for sustainable green buildings with facade solutions.
Good afternoon, everyone. Thank you for hosting me here with you. My name is Khamis Majdubah. I am the Solution Manager from Saint-Gobain in KSA. Today's topic is meeting the demand for sustainable green buildings with facade solutions from Saint-Gobain. I'm sure a lot of you know Saint-Gobain. Just a refreshment who we are. Saint-Gobain started in the year 1665 in Paris as a glass manufacturer. Then throughout the year we witnessed a lot of expansion, going international, and diversification of activities like the mortar, the gypsum board, and the insulation, until the present day, where we are all activities are working together as solutions provider, rather than just selling individual products. We are, of course, trying to honor our commitment to the future of neutral emission by 2050. Innovation, of course, drives our business. We are one of the top 100 most innovative companies worldwide. From the 170,000 almost employees of Saint-Gobain, kind of less than 4,000 employees work in 8 different R&D centers worldwide. A little bit about our presence in the region, in the East Mediterranean and Middle East. In the top map, you can see our industrial footprint, how we are distributed with the mortar activity, insulation, gypsum, Grizo, which is our concrete admixtures, the abrasive and the glass also in Egypt. In Saudi Arabia, we have Weber, which is our mortar activity. It has been established in the kingdom since 2007. And we have 2 factories, actually, one in Riyadh and one in King Abdullah Economic City. The other factory that is available is Kimco Isover, which is our insulation activity, where we produce the stone wool in Yambor. Both mortar and insulation, we are more than 400 employees in the kingdom. Of course, there are other regional activities that we are working with, like the gypsum, Gyproc, it's coming from Abu Dhabi. And of course, building glass is coming from all over the world. But in the region, in this cluster, our float line is located in Egypt. Definitely, you might know some, I'm really sorry for that, some other international activities that we have, like Vetrotech, which is our fire-rated glazing. Sage Glass is our electrochromic glazing system, Glass Solution, Adforce, Ecophone, the ceiling tiles, Norton, Solar Guard protective films, Swiss Spacer, which is the warming edge technology for spacers, Pont-à-Mousson, PAM, which is our piping activity, International Timber, we'll talk about it in brief. Grizo also is our concrete admixture company and activity in the region. Starting with our facade definition, how do we define facade in Saint-Gobain? We define it as 2 components, the structure and finishing. Structure could be a solid, of course it could be concrete or block, load bearing or none. It could be lightweight facade. This is what we call lightweight facade. It has two distinction and major types, which is the infill type and the curtain wall. The finishing is, has different examples. I'm going to speak about a few of them in the coming slides. I will emphasize the ethics. I will talk about the lightweight facade system and about the glazing. Ethics, of course, ethics stands for Exterior Thermal Insulation Composite System, or the EIF system, as many know it with that name. We call it Weber Therm MW. MW stands for mineral wool. Mineral wool. And this is a distinction in Saint-Gobain. This is how we differentiate, that we use the mineral wool. Another differentiation is that the complete components, the whole components of the system, they are from Saint-Gobain. Everything, the glue, the base coat, the anchors, the mineral render from Weber, the mesh from Adforce, the stone wool from Kimco Isover, and the whole system is guaranteed as a whole. Some characteristics about the system, I'm going to talk about them in the coming slide. The economic value, thermal insulation, fire performance, and no condensation technology. When you talk about economics, I'm not going to speak about theoretical calculations. In a nutshell, this is a study of saving energy that has been done in Kuwait for a period of 1 year of 3 adjacent villas, B1, B2, B3, B1 with AAC block, B2 with 6 centimeter of ETICS insulation with the ETICS system, and B3 with 12 centimeter of ETICS system as exterior facade. These are the exterior surface repartitioning, the wall, the beams, and the glazing, and the interior temperature set at 23 degrees Celsius. When we did the simulation of the surface temperature, this is the average values that we achieved. In conclusion, B3 compared to B1, we can reduce almost 30% in cooling energy and peak load, which results in less CapEx by reducing your AC systems and also in your OpEx. Of course, this study is documented and we are available for any question you might have. Thermal comfort. We start by talking about the thermal bridges. Thermal bridges, if you have a look at this small picture, it's a comparison between the uninsulated, the interiorly insulated, and the exteriorly insulated system, which is the ETICS, that's what we are talking about. Clearly, it prevents the thermal bridges, which in return decreases the construction thermal dilatation, which of course can be translated into being preservation of the natural resources. Another function, of course, that it is a decorative material, for sure. Talking about compliances, everything is documented, as I said. We are in compliance with ASTM, the ETA 004, and the Saudi Building Code 601, 602, and with the SASO. Talking about the fire, according to EN 13501, some of the gentlemen here were talking about the importance of fire and norms. We are achieving Class A in the EN 13501. And according to ASTM E84, which talks about the flame threat and smoke development, again, we are also at Class A. That's because according to EN 13501, it is only the mineral wool that is not non-combustible material. Condensation inhibiting in the building envelope, this is actually a big topic. So I'm not gonna talk about details a lot. In a nutshell, the components of the system, they act as condensation inhibitor. This is evident by the mu value, which is the water vapor diffusion resistance. It has low water vapor permeability and reduction in water absorption by 95% according to ASTM D870. And also, it has passed the water penetration in compliance with ASTM E331, E330. Of course, it's a crack bridging considered, and it regulates the substrate to prevent condensation likelihood. The second system, SFS, steel framing system, facade solution. We call it the lightweight facade system. When we talk about lightweight facade system, we talk about Glass Rock X. Glass Rock X is a new generation gypsum board for exterior applications. It is wide branded glass mat with UV resistance, and it can withstand weather conditions for 12 months without having the exterior finishing applied over it. It comes in two different systems. The first system is what we call the curtain wall type, where the framing is outside the floor slab, as you know. The infill type, where the framing is between the floor slab, as like this. Sorry. Again, the system is fully provided by Saint-Gobain, all the components from Saint-Gobain, the plaster board, the sound block, the exterior Glass Rock X, the metal studs, the glass wool from Kimco Isover, also the direct render, which is the finishing system, it's all from Weber. It comes with two different, let's say, finishing systems. It could be either a direct render applied on top of it, or the ETIC system, which we just talked about, itself can be applied on the exterior surface of the lightweight facade. Talking briefly about some of the characteristics, this is a comparison between the U values, between the two finishing systems. The first with direct render, 0.23, and it can be reduced down to 0.1, using the ETICs as an exterior finishing. Fire, why it is very effective in fire control, and this is actually due to the unique behavior of the gypsum itself. Okay, that because each 1 square meter of wall of gypsum board, it contains 5 liters of water. So it prevents the fire to go above 100 degrees Celsius. So in return, the glass fiber, also the calcined gypsum formed on the face of the gypsum board, it retards the hydration process. If you have a look here, we have two systems, one 60 minutes fire rated, and the other is 120. The only difference between them is the addition of extra plasterboard on the inside, without changing anything. Talking about acoustics, definitely you know that dry lining relies on the mass spring mass principle, okay, rather than the linear mass principle. With that being said, the lightweight facade system with the ETICs on top of it can achieve 70 decibels noise reduction according to the RW value. Structural calculations, we are going to provide this to you. We take into consideration the load factor combinations, which is the dead load, live load, wind load, the limiting deflection, the clear height, and the width, which is the footprint of the panel. A quick comparison between, the block work and the lightweight facade. In fire and impact resistance, both of them, they work well. But the lightweight facade is actually superior in acoustic performance and in thermal performance. It's 98% less water consumption, which means that it doesn't need water or sand, sorry. It's much faster, much lighter, and consequently, it doesn't need a lot of deliveries to the site. The last is glass solution system I'm going to talk about. I'm sorry for that. I don't know why it's keep. The product range is just a refreshment of what we have. The non-coated glass, we have the Plani Clear or the Plani Lux, which is the crystal clear glass. Diamant is our extra clear glass, and Parsol our tinted glass range. For the solar control, of course, I'm choosing the solar control here because this is what matters more in this part of the world. The Cool Light family, we have the ST, the KNT, the SKN, and the triple silver, which is the extreme, which has the highest selectivity. Of course, selectivity is the division of light transmittance by the solar factor. Of course, Sage glass is our dynamic electrochromic glass, where you can have different shades and tints as well on the same panel. The overlength, talking about the overlength, we can achieve up to 18-meter length of a glass, of coated glass. And this can be treated, of course, heated treated, processed, double glazed, triple glazed, etc. Some services in the design stage, we offer to help the architects, design offices also with some of the simple services, like the sun path analysis, solar exposure analysis, the lux level, structural support analysis, the wind load. We do some code compliance and also payback analysis. We can provide that. And for the digital services, we do have the Calumen Live, which is a tool online available to everybody, to calculate the thermal and daylight performance, the acoustic performance through iZakwo, which is also a tool online available. And for the aesthetic view, we have the Glass Pro Live, which is our rendering service. It comes in 3 stages. The first stage, where you can discover our range of products only. Then the second stage, you can view it on a predetermined building. The third stage is to visualize it on your own 3D model building. We use a science called physico-realistic, which is a non-biased science. This is an example. So this is the art, how it has been designed. And this is the science we use in Saint-Gobain to render and to simulate the building. And this is in reality. So you can see how much close they are. Another example is our Saint-Gobain tower. This is in Paris. You can see the difference, very little. And this is another project in Poland. Actually, we do have a tool outside in the booth. You can have a look where a VR camera is available, and you can have a glimpse about it. Last, about the glazing, the RFID, radio frequency identification transponder. It's an implanted device within the double glaze unit. We call it iWin, where the glass is a data carrier. It can be used for BIM modeling, for on-site access, for recycling the data provision, for end of life, and so on. Some other facade systems where our Kimco Isover company, they can contribute with their mineral wool. For example, ventilated facade, the ACP cladding, the curtain wall, the GRC, stone wool cladding, and also the non-ventilated, which we talked about, the ethics and the cavity wall. Sorry. Last is our high-performance engineered timber solution. This brand is called Akoya. It's a chemically modified wood. It can be used for decking, cladding, and bridges, and it is for very harsh conditions. It has been used here for severe conditions, actually. What distinguishes it is that it has an FSC certification. It has a warranty of 25 years in ground and 50 years above the ground. What it offers, exceptional durability, up to 70 years service life by Trada. And this is a quick comparison with other wood species in the world. It has stability, resistance to UV degradation. It has insect and rot resistance, and of course, longer coating life and low maintenance. That would be all. Thank you very much for your listening. Thank you.
Thank you so much, Khamis. for this very technical presentation. And now, guys, as I have told you, Giovanni has not made it. He is sick. However, we do have a surprise presentation for you. It's not on your agenda. We have Mr. Nicky Heys, Associate Director of Mindheart Facade Technology, who has accepted to make a presentation on very, very short notice. So I would like to thank Nicky very much for accepting this. And please welcome him on stage. Nicky.
Okay, good afternoon. Is my mic working? That's good afternoon. Yep. Okay, for those of you who are surprised to see Mindheart Facades presenting today, you're not as surprised as I am. I got here as a guest. I think I'd been here for 1 hour, and I was asked if I could step in and say a few things. So I hope Giovanni's feeling better soon, and I hope I can do the slot justice. Just a couple of words about myself. I arrived in the Middle East about 17 years ago, working in Dubai, on Dubai Mall. I was there for 4 years, and then opened Mindheart Facades office in Malaysia about 12 years ago. I've been back for several months as the Kingdom's representative. So Mindheart Facades now has representation here, working out of our Riyadh office. With regards to the presentation, this was put together super fast, and it's the reason I wanted to tell you that I was running the Malaysian office. There's a couple of case studies in here that are from Malaysia, but they are relevant. They're still appropriate for what we do over here. So the presentation is under pressure, and this was developed as a response to a question or a series of questions that we got asked repeatedly when we were meeting clients and proposing our services for facade consultancy. And that was regarding wind tunnel testing. And clients asking, what kind of testing would you recommend that I undertake? How would you work with the wind tunnel teams in my interest? And what kind of savings can I expect? Now, the what kind of savings can I expect question is really tough, and every project's different. So the short answer is, it depends, but that's a horrible answer. Clients don't like that. So over a period of time, we thought, how can we be a little bit more informative or give a client something that they can consider? So this is quite a snappy little presentation that tries to answer those questions. Firstly, I want to say a big thank you to CPP, who's one of the wind tunnel testing teams that we work with. And we've worked with many, but we have a tight collaboration with this team working out of Australia. And they helped with the slides. So I need to give them a big thank you. They don't know I'm doing a presentation today, but then again, neither did I. So there's some information about them there, and a website at the bottom, so you can look at what kind of services they can offer. So today we're going to look at 2 case studies which demonstrate how external or wind pressures can affect facades and why careful consideration is required. The first is Ilham Baru Tower in Kuala Lumpur. This is a project that we undertook with Foster's team. This is a mixed-use development that had a megastrut of diagonal cladding with diagonals cut out. I don't know if I can use the pointer in here. Is anybody seeing a pointer? Yeah? Diagonals cut out here, so we had external decks, and we had the same on the ground floor, which we needed to consider. This was a 60-story building. It's almost a super skyscraper. It's about 275 stories. So I want to take you through the considerations regarding wind on this. And then the second is another project from Kuala Lumpur, which the wind tunnel, we brought in the team. So they worked directly for Mindheart Facades. And they came late. The client decided to pull the trigger and do the study. So we had a scheme that was pretty much finished. And it's about 30-plus story. It's not a huge tower. So we had the detail, we had the cost plan. We undertook the wind tunnel testing. We used those figures in quite a creative way, and I'll show you how. So I can show you the before and after figures of that, so we can partly answer the question. So firstly, Ilham Baru Tower. So 58-story, about 275 meters, as I was saying. And then, as I pointed out, we had those those inclined surfaces here, these diagonal curtain walls, and this beautiful diagonal megastrut cladding, which was stainless steel in 4.5 meter lengths, put together as one panel. So let me point to. Can you see my cursor? I can't see my cursor. I'm going to do this the old-fashioned way. Okay, so this is 9 meters, and we had the 4.5 and the 4.5, which was the full length of the panel. So these were factory fabricated and then built and placed onto the building. So the facade comprised of a unitized system with low E glazed DGUs, a ceramic frit in the spandrel locations. That's the black band running in between where the floors are there. We also had a frit in the what we call the privacy frit. That's really not helping me at all within these areas here. And we had these diagonal louver blades that were placed in to provide shading. And with a combination of the high performance glazing and those diagonal shades, we managed to achieve. Are you coming to try and sort that out? What do I? And wave it about. I don't mind running backwards and forwards. So here's a view of the visual mock-up for the project. We selected the starred node point within the cladding zone because we wanted to see how the contractors could put these panels together and whether we could get sharp detailing within the corners there. The glazing that we used had a light transmission of 31 and a shading core of 0.26. This is going back around well, almost 10 years. So at that time, that was a very high performance. You can see from the outside, the glazing looks black, but when you're on the inside of the building, with it being a grey, neutral colour, it looks perfectly clear. So this was considered to be quite desirable. See a slim version of me there as well. That's how long ago it was. This was the study that we undertook with Foster's on the diagonal louvers. And we managed to reduce the solar heat gain by 40%, thus giving us our platinum rating lead. And this was a performance test. It was an absolute monster. 5 stories. We couldn't find anywhere in Malaysia to do this, so we went to Thailand. We had 5 stories of unitized panel, and we had the diagonals that are just behind these elements here. So we managed to test all the different systems. We had internal drainage running inside that cladding. And because of the size of this performance test, it gave us the opportunity to remove parts of the cladding and replace with different profiles and look at how to remove the water, especially from these kind of surfaces here. So you get the water building up in the corners, and we wanted to try and prevent staining on the panel surfaces. So we spent quite a lot of time playing with that cladding and looking at reveals and joint sizes and how best to treat that to stop the staining. And then for tall buildings, ideally, when you're going with a unitized assembly, you want to be launching the panels from the floors. So you stack your unitized panels, you launch them slab to slab and drop them into place. You're working from the inside of the building, and it makes the installation a lot safer. You don't want people on the outside if you can avoid it. But we had to book the trend with IB towers because of the megastruts. And you can see here the size of these. So this, going right the way across here, is one panel. So we needed these mast climbers in place, really for the megastrut cladding. And that's how we went about the installation of this, whilst doing the unitized assembly in a more traditional method. So the actual geometry of the building looks relatively straightforward and clean, and you would expect that it's not too complex. But when you consider that with a unitized panel, you want to be fixing to where the beams are. So for these panels, for example, they're all going to fix to this beam here. And when you start to get these triangles, there's no beams anymore for any of these panels. So it does get kind of complex on where you load them. And also the drainage path, when you have water running down into the heads and you're doing all these diagonals, you're not really flushing out the water in the same way. So I won't take you through these details, but we've got some very complicated interfacing of the unitized panels. So moving into the wind tunnel. Firstly, we designed the building to the Malaysian codes, and we were getting a pressure of 2.2 kPa. And that's shown on this diagram here on the left-hand side. And when we undertook the wind tunnel testing, we were finding that we didn't go beyond 2 kPa. And quite often it was 1.5 kPa. So what we tend to do is we don't take the highest load, the highest wind load. We take the average, or the one that we can utilize the most of, and we engineer all the systems to meet that. And then for anything that goes above that, we would strengthen and stiffen those elements, and that gives us a much more efficient system overall. For the external decks, particularly at level 37, we undertook pedestrian and wind-driven studies, along with thermal comfort studies. And the concern on this particular deck was we had restaurant areas outside, and we were seeing that the studies indicated that glasses may be blown over, napkins were flying. It was very blustery there. So we had a 2.4 meter barrier, glazed barrier, and a series of planting that helped to assist in that. And you'll see at the photograph on the top right there, the water is calm, it's not splashing over the deck. But if we hadn't have introduced all of those elements, then we would have had a lot of problems there. The architects really wanted to open up that deck, and they liked what we did on the Dubai Mall. The photo there that's on the right, kind of in the middle, is these bifold door systems that we created whilst doing the Dubai Mall that had a openable door in this one here. I'm not going to jump. Anyway, it could open. And within the press of a button, it took about 5 seconds, that curtain wall then becomes a canopy. The door swings the other way, so it can't open by mistake. It was like something out of Transformers. And we've installed all of these many years ago, and the Foster's team loved that idea and wanted to have those installed where I've got the red diagrams here, and to have those open throughout most of the day. So they'd open in the morning and they'd close at night. But when we undertook the wind study, we found that through having those doors, it was creating a pathway where we got the wind coming in and into the lobby. Every time these doors opened here, that wind would give problems to the lifts. It would cause potentially the lift doors to jam and for the lift to shake and be noisy. So we couldn't do that, and we had to go instead with a lock system. Let me just jump to. I think there's a video that I'm going to try and play. There you go. That's one of the Foster's guys using those doors. The doors are at a slant because it's an inclined wall, but we had quite a smooth system there that was working pretty well. So we went with the airlock as opposed to the transformer bifold doors. Now just going back one slide to here. So there's two concerns. When we're looking at that lobby space, not only the lobby, but the lift shaft in general. So we've got direct air paths, or potential direct air paths that can enter the building, make their way to the lift shaft, and then dump through the shaft and out of the front entrance of the buildings. So air can come in through a series of, if it's a hotel, maybe you've got operable doors, or you've got balcony areas. MEP zones or any other area on that facade can allow air to go in, and if that's not controlled and can find its way to the lift shaft, then you have a problem with the air traveling down the lift shaft. Also, we've got cold air drops, warm air coming in and rising. So in climates where it's hotter outside, you've got the adverse happening where the hot air is going in through the entrance and it's pushing up through those lift shafts. So we have something that we call stack effect, where the cold air is rushing out, and so it's affecting your energy, it's affecting your aircon, and it's also creating these pressures that are detrimental to your building's performance. So I showed you the solution for that. And then the final study undertaken on this particular building was rain infiltration assessment at the ground floors. So we saw that without the canopies, and the canopies were not there originally, we were getting too much driven rain, even though we had an inclined wall. The rain would come in and enter through the entrance, so we've got a discrete canopy that just stopped that. So that kind of gives you a feel for the different types of studies that the wind team can do, which will impact and influence not only how we work, but as for the architects as well. Right, case study number 2. How much money can I save? So as I was saying, the wind tunnel came in late, so we had a design, we had the cost. So the facade used a unitized system, and this was a relatively standard unitized, mounted at the floor areas. And the next slide shows you then the just one panel, and you can see that the panel here is mounted at the spandrel area. We have a bullnose. We'd unitized the bullnose as well, so that was in 2 parts, which meant that we could install the bullnose to the panels before we launched them. So there was no working on the outside of the building here, which is the ideal way to go about doing a tall building or a unitized assembly. So once we'd done the wind tunnel test, we took the client team, to the testing laboratories, and we could stand inside as the turbines were switched on, and they gave us these little wool tufts. So you've got a rod, it's like a long stainless steel rod with little wool, and you can move that around the building, and it gives you kind of a preview as to where the higher winds are when your wool starts to really move. You know that there's a lot more wind there, and what we were finding was a lot of wind at the crown of the building, which wasn't a surprise to us, but also a high buildup of wind at the podium area on top of the canopy, because what was happening, when the wind was striking the building, it was going in 2 directions. So we had quite a large buildup just on that canopy area there. So, yeah, you can see a little diagram there of that in service. So what we did, because the wind tunnel guys were part of our team, it gave us an opportunity to have a tighter integration with them. We had a double glazed unit on here that was 10 millimeters thick, 1010. So we looked at, if we went to 8.8, what would that be able to take? And it was 1.6 kPa. So we told CPP, run your wind tunnel, but monitor 1.6 kPa and tell us how much of the building can accommodate that. And what we were finding was that all of the center of the building could accommodate that. It was only the crown area, where you can see on the right-hand side where you've got the yellow at the top, and some area right down at that canopy, which was going beyond that. So that gave us the opportunity then to reduce the glass thickness in those main areas. Here you are. So that's explaining all of that and the 1.6 in there, and the diagram showing those figures. So that gave us a saving of $450,000 just on the glass alone, if we were undertaking that one exercise. Next, we looked at the aluminium. And we undertook aluminium, it's easier to find your savings. Glass is very difficult, because if you get one area where you go above on a typical glass, you can't swap and change glass, especially if it's tinted, because it'll look completely different. But for the aluminium, we can streamline, as I was saying earlier, to the middle levels, and we used the 1.6 in this instance. And we saved, we went from 10.4 kg per meter run to 6.8, and we saved $660,000 on the aluminium. So the next slide just summarizes those savings. And this was just on materials. We didn't look at any other elements. We just literally took the glass, the aluminium, and we got a $1.2 million saving on that exercise alone. And when you consider that we brought in the wind tunnel test at $20,000, that's quite a return for your money. So the client was very happy, and I hope that this gives you a little bit of an intro into how the wind tunnel testing can be utilized. And I know that this is just one project, but at least it's it's an indication. On a very conservative building, it looks like it's it's always going to be useful and cost effective to undertake the tests. Thank you.
Thank you so much, Nicky. To go from a delegate to a speaker is something fantastic, honestly. Don't know what to say. Thank you so much, Nicky. For our next speaker, we'll be talking about designing with laminated safety glass interlayers for security and sound control applications. Please welcome on stage Jochen Regenauer, Head of High Performance Products at Kuraray.
So let's start. Thank you very much for the warm welcome and especially for pronouncing my German name in very, very correctly way. So it's not as easy, especially not for the non-Germans. Yeah, I'm try to introduce myself a little bit. So I'm Jochen Regenauer. I'm in charge of the high performance product segments for interlayers within Kuraray. Who is Kuraray? Kuraray is a big chemical company. The origin was in the fiber business. We are now still doing the big fiber business, for example, in concrete, to make the concrete even more stiffer, to do structural elements in concrete. But we are also very big in water solvable solutions. For example, if you're having any detergents at home for the wash machine, and you have this kind of lovely foil outside which disappears, and we are covering with that 90% of the world demand, the global demand. So that is 100% solved and no microplastic. So, but not talking about now water solvable interlayers. Let's talk a little about Trosifol and Sentry glass. For a lot of people, Sentry glass is well known because it's a very structural. It's a structural product which is possible to increase for example, the glass dimensions, or to decrease even more the glass thicknesses. PUBs with all kind of functionalities, you see it here, performs with safety, decorative, acoustic, structural, and security. We are dealing with specialized applications, but we are also very big in automotive. But today I'm just focusing on the architectural part. So today we will touch just the safety, acoustic, and structural and security. Yeah, security glazings, we all know that. It covers a lot of, I would say, areas. But at the end, everything is about safety. And we are talking about safety means decrease the loss of lives and also property. And at the end, by threat from individuals and also from the nature. And especially the second one, by nature, is in some parts of the world heavily increasing. So we are very big in the hurricane business, for example, and also typhoons are more and more common in Asia. So therefore, a suitable product, for example, is the Sentry glass. But I'm not only talking about terrorism. It's often facades, especially the first level, are, let's say, a soft target for angry mobs. Here on these three pictures, you see also the performance of a glazing on the left side. That is quite well designed. So I think the people have some stress to get in. In the middle one, that is a new trend. That is kind of a minimal framing. That is what we see, especially in Central Europe. That's a common thing, that the profiles are sometimes so minimal. That means at the end, the glass fits very well. The composition of the glass fits very well, but at the end, the framing, especially in the first levels, are not as suitable. And on the right side, you see it a complete wrong glazing. That is just a tempered glass, which has quite obvious no safety performance at all. For man-made threats, let's categorize it in three levels. That is the forced entry, that is the bulletproof or the fire attack, and the bomb blast. Unfortunately, all three segments increased heavily within the last, let's say, 10 years. Forced entry is a kind of a standard in, yeah, I would say kind of a global scale now, but still there's some, yeah, some things are common. Just a refreshment. Everybody is aware about that. Annealed glass, from annealed glass to laminated safety glass, annealed glass is not considered at all as a safety. If it breaks, you have a lot of sharp splinters. If we're talking about tempered glass, which is 4 times stronger than annealed glass, you have to heat up the annealed glass up to 620 degrees, then rapidly cool it down. Then you're getting the pressure into you have then a high surface pressure, and that gives you a kind of a safety performance. Just a tempered glass is, for example, well known for the interior, like in the shower business. For exterior, I personally think safe. It's not a real safe one. But let's talk about laminated safety glass. What is a laminated safety glass? Laminated safety glass is a sandwich of always 2 glasses or even more glasses of a PVB. It's a interlayer or a sentry glass, 2 different chemistries, 2 complete different chemicals and also properties. So, and there are also other interlayers available, like the EVA, or sometimes you have a combination from polycarbonate and polyurethane. So, but it's just, so the most common are the PVB and the sentry glass film, which is produced by us. By the way, we're doing roughly per year 90 million square meters of interlayers for laminated safety glass. I will not tell the share between PVB and sentry glass, but it's a significant share which we are now generating with the sentry glass. So let's talk a little bit about the code work. So I just put some figures on here with the EU and the US code work. In the EU, we always have for the forced entry the EN 365. It starts with the lower glasses from levels from P1A goes to P5A, and if you want to have a further enhanced security, it goes. You have to do the X testing for the lower levels. It's a ball drop test. It is an iron ball which weighs 4.1 kilogram. So it drops on the glasses, and then it gives, let's say, hopefully the glass fits to the security level. So for example, the axe test, it starts with 30 strikes, and the highest level, the P8B, ends with a minimum achievement of 77 strikes. So then you can imagine how, let's say, how big the force should be. So in US, you have the STM norms. For the window systems, it's for US, it's quite easy. You have also the STM, and in Europe, you have the ENV. Here's a short video about, I'm a big fan of to be realistic as much as possible. Here you see the comparison between PVB and sentry glass, and it's room temperature. It's not Middle East temperature. So. So roughly, I think, 11 seconds. And now with the sentry glass. So it takes some time. Let's say it takes some time. As I mentioned, that was just room temperature, and if we are changing now the temperature scenarios, especially to the Middle East temperatures, a PVB, an easy example is a balustrade, or we are, let's say, often consulting a balustrade business. Let's say just one side supported on the bottom, these are the fixing, and a PVB has, if it would break, there is no resistance. That means the balustrade would complete, or the glass would complete collapse. And if you then use then the sentry glass. That is a complete different story. It stays in a very rigid way. So some ballistic codes or let's say standards. So it goes from BR1 in Europe up to BR7. What is the difference? The difference is it's the caliper. It's from a very small one up to a caliper and the speed, for example. And that is, I would say, the major difference. It covers in the EN 1063. And there is one big difference if we are talking about bullet resistance. There's always a kind of a requirement for spall or non-spall. So what is a spall in general? You always have to decide which the bullet came through. And then on the inside, that is always, it should be the safe side. But there is no real regulation out that says, okay, do I have to have a non-spall glass, or do I have a very safe glass? So it's really up to the specifications also. There is a solution outside, which is quite easy, and that is you have to have a composition. It could be with PVB, a glass combination out of PVB and float glass, or tempered glasses, it depends, or it could be sentry glass, and then to create a kind of a safe side where you can add a kind of a PET, we call it spall shield in it, on top, and then it's a hard coating which with anti-scratch. So that is quite easy, and that is well known, especially in the military industry, but also in the embassy business. What are requirements? That is quite interesting. We've been also not aware about that. Requirements in the architecture business for bullet resistance. Banks, financial institutes, Central Europe, quite low, but still in place. Police stations are getting definitely. Also airports are. That's a very strict requirement now. And embassy and military business are, so that means, and that is not only bullet resistant, then we are talking about also bomb blast. What we did is a kind of a testing to see really how, usually you have a glass composition. That means really you have the float glass and we have the PVB and or the sentry glass. We shoot it, an interlayer block, even here you see the dimensions, and then the result of that we have the DOP, we call it the depth of penetration. And this is how it looks like. Then you see clearly there are some advantages of some interlayers, which is not related to the glass, but it's really, you see that a PVB, there's quite, let's say, a weaker performance than with a sentry glass. And I need to speed up a little bit. And here you see really, we also did that with polycarbonate, which is a quite common solution for bullet resistance in the market. What is the challenge with polycarbonate or glass polycarbonate claddings are, let's say, quite challenging in terms of shelf life, especially if you're having high temperatures, because there's a different expansion. So that means with the sentry glass product, we will achieve, let's say, kind of the same results as with polycarbonate, but everything depends at the end to the glass composition. So here you see a different formulation. That means we shoot it officially. That is a BR3 classification on the left side with the sentry glass, and on the right side with a PVB setup. And what you can see is really that in terms of thickness, if you choose the right interlayer, you can save 20%. And also that means in total, in terms of weight, it's 20%, and that's quite a lot. Sound control, I have to rush a little bit. So in physics, that's very easy. Sound is a mechanical wave that propagates through a transmission medium, gas, something solid, and or liquid. But what is noise? Noise is usually something really negative, and what is unwanted sound at the end. So urban noise, that is definitely a hot topic since a few years, because we have clearly a concentration of the majority of the people in the cities. That means the traffic or the infrastructure for traffic is not suitable, maybe to deal with such a lot of people. So there is a need, there's a strong need to have more insulation. So, and just one message is everything is below 3 dB, that is not noticeable. So it's really, you can't hear that. So, and 5 dB, okay, you hear something, and if you then go to maybe 10 dB less or more, that is, you get a feeling that it's doubled, or let's say half of it. How can you achieve a kind of an insulation? Or you can double the mass, that is easy, but usually not wanted due to the weight. What you can do is you go from a single glazing up to a laminated safety glass, or even, let's say, go straight forward to achieve even better results. You combine it with a acoustic interlayer. So these two choices are available on a global site. For the Middle East market, there's just one choice, and that is the monolayer, because due to the high adhesion to the product, to glass, it will be suited very, very well. Here are some rules. Doubling the mass, 3 dB. If you want, let's say, to go from a monolithic outer pane in IGU to go to a laminate with a structural interlayer, that brings you not too much, because we are talking still about a stiff product. So you can see, I think the biggest impact is if you're really going from a monolithic IGU from the outside to acoustic laminated glass, then you will achieve 4 to 5 dBs more, which is significant at the end also. That is new, and that is something we did a lot of work on that. And it's the first acoustic calculator based on artificial intelligence that is available now on a homepage, so you can easily use that. So these are 3 pictures. So on the left side, you see really you can choose every single glass composition you want, and then you can adjust the glass thickness, the interlayer thickness, or the cavity from the spaces. And at the end, in the middle, you see the setup, and then on the right side, there is the prediction, and that is by RW, STC, or OSTC, and you can say, okay, how good is that, and everything, and we confirm it's really more than good, because everything based on, we did hundreds of testing documents. Usually, if you have to do an IGU with a dedicated sound control value, you have to test that, and we put all this knowledge into that system combined with artificial intelligence. So that means that is a quite easy tool and a user-friendly tool. So you can download it as an app. A little bit over time, but hopefully you enjoyed that. Yeah. Thank you.
Thank you so much, Jochen. Our next speaker could not make it from China. We have Chengde Huang. So we will have a video with a short introduction about CSG, and then a video of a presentation from him.
What attracts the attention of the world? What tops the prosperous peak? Who leads the trend of energy-saving building glass? China Southern Glass Holding Group Company Limited. Founded in 1984, CSG became the first listed company in the industry in 1992. From the first introduction of foreign advanced technologies to the possession of internationally leading R&D level. From a leader of the industry in China to a global famous brand. With over 30 years of persistent pursuit, CSG has set up many milestones in China's building glass industry. with more than 20 subsidiaries and 5 top building glass production bases in China. CSG has established a complete production chain of quartz mining, float glass production, low-E energy-saving glass processing, and its capacity tops the world. CSG is leading the new trend of building glass in China and even in the world. People turn sites to high-rise buildings due to the high-speed global economic development, urban population explosion, and land scarcity. Glass as the essential material of high-rise buildings, its safety and energy efficiency have been focused on by society. As the industry leader, CSG has been continuously developing a series of safer, more energy efficient, more comfortable, and more beautiful products with its strong R&D capability, which widely meets the fast-growing building demands. Buildings like solidified poems and vivid paintings, turning buildings into art to show city classics, decorate the world, and realize harmonious development of building and city with our products. Energy efficient and comfort, we make quality goods. With safety and beauty, we set up a leading brand. Pilot of energy-saving building glass. CSG Holding Company Limited.
Hello, ladies and gentlemen. This is Chengde from China Southern Glass, the leading low-E glass manufacturer in China. Today, I'll talk about our understanding of the performance of low-E glass and application experience. Hopefully, it will be helpful for doing projects. My presentation will be in 3 parts. First, effective of heat accumulation. The second, aesthetic effect. Thirdly, jumbo size IGU. First, let's talk about effective prevention of heat accumulation. As everybody knows, solar radiation contains 3 parts of energy: 47% visible light, 51% IR, and 2% UV. In cities, buildings are always surrounded by other buildings. Low-E glass on the surrounding buildings reflects solar radiation. Low-E glass reflection contains about 10 to 45% visible light and 55% to 90% IR radiation. The shortwave IR is the major cause of temperature rising. To create a cooler, comfortable room space, it's a must to prevent the IR radiation from entering inside. This can be achieved by proper application of low-E coated glass. The long-wave IR radiation from the surroundings can be effectively limited by lowering the U value of the window glass. When doing projects, glass performance is always specified by G and U value. Let's look at the transmission spectra of 3 different glass products with similar G value. It's clear that visible light and IR transmitted have substantial difference. The more IR transmitted, the higher the room temperature, and the least the visible light. Let's see technical data. In this table, 5 typical glass products are listed or on clear glass, only the coatings are different. They have similar G value. However, the IR and the visible light transmitted are not similar. With the lowest IR and the highest visible light transmittance, 777 low E is the best in energy efficiency. Next, let's look at the effect of variation in coatings and substrates. To meet performance needs of a project, we may have different approaches. Here we show 3, with different coatings on different glass substrate. Obviously, 777 low E on low iron glass is the best, with the lowest IR and the highest visible light transmittance. Furthermore, let's say the effect of different substrate on the same coating. We apply the same 777 low E coating on different substrates: low iron, clear, green, blue, and light gray float glass. As tinted glass is used, the G value may be lowered. It looks like a better energy efficiency. However, with tinted glass substrate, the short wave IR transmitted inside increases, which leads to higher room temperature. Not only uncomfortable, but also more energy consuming of air conditioner. The above data of different approaches give us a clear conclusion that to create a bright and cool room space, 777 low E on low iron substrate is the best solution. With 777 low E coating on low iron substrate, we can get more visible light, less shortwave IR, effective prevention of heat accumulation, and a more comfortable and lower electric bill. This diagram shows transmittance spectra of different 777 low E glass products. They all have extremely low transmittance in the shortwave IR range. So when doing projects with 777 low E, we only need to consider how much visible light we need and the color and the brightness. Then let's talk about aesthetic effect. Aesthetic effect is affected by color, consistency, reflectivity, brightness, color rendering index, etc. One important aspect is the spandrel matching. Here we will talk about a little more on the spandrel matching. By applying fluid pattern on number 3 surface, we have achieved perfect matching for a number of projects with different colors and brightness. Here we show a few examples. This is green look 777 low E. You can see the spandrel and vision glass matches perfectly. This one's a light blue 777 low E. This one's a neutral look 777 low E. This is gray look 777 low E. This one is a neutral look low E. This one is silver gray low E. Again, neutral look low E. And next, I will spend a little time on jumbo size AGU. CSG as the leading low E glass manufacturer in China since 25 years ago. Along the years, we have done numerous projects in China and overseas. And a number of projects is jumbo size AGUs. Here, we just list a few examples with jumbo size AGU panels. The maximum size we have done is about 3 meters by over 10 meters. We show here a few pictures of real projects. This AGU with a height over 10 meters, this project is in China. This one is a project in UAE. That's all of my presentation. Thank you.
All right, guys. For the final part of the conference, we will have a panel discussion. However, we're missing 2 panelists, so it will be we will do something interesting. We will try to have 2 panelists and have the audience participate with us. So we will have microphones around, and whoever wants to speak can raise their hand, and I'll give them a microphone. So hope that sounds okay. The panel is titled On Facades, Ecology of Character and Identity. The moderator, Dr. Hazem Sabbagh, founder and creative director of Craft Architecture, and our panelist, Turki Gazzaz, founder of Brick Lab Architect. Please, welcome on stage.
Hello? Yeah.
Hello. Hello.
مش الحال؟
مش الحال.
All right. Omar, shall we start? Shall we start? Okay. Good evening, everyone. Oh, good afternoon, sorry. I guess we're just feeling a bit tired toward the end of the day. We need a nap. Okay, so you know, this whole conversation was supposed to be set last June, and we had initially a few other panelists who Dr. Ziad Azam and Dr. Noura Ghabra, who just the last 2 days, one of them had to be out of the country and the other had schedules that she couldn't get out of. So the preset sort of obligations from June somehow didn't materialize. In any case, just to give you a highlight, because we wanted to focus the conversation onto Jeddah. Now, before I start, and you've seen me this morning, I would like to introduce architect Turki Gazzaz. He's a founder of Brick Lab, an award-winning studio here in Jeddah, and he's been significantly engaged in multiple projects across the kingdom, specifically ones that are culturally specific and with lots of public engagements as well. I'll let him address that as such. But in our conversation with Dr. Ziad and Dr. Noura, our hope was to raise some questions regarding all these potential developments that are happening in Jeddah. Dr. Ziad, obviously, he's working with the Ministry of Culture in the heritage evolution of the downtown, and Dr. Noura, who's a professor at King Abdulaziz University College of Architecture. She also works and did most of her research on the notion of facades and its contribution to cultural expression, etc. So in a sense, we wanted to to step back, because Jeddah as a contemporary city, and Turkey can shed a historical depth onto that, because he just sort of closed a very successful exhibition called Saudi Modern, which talks about the modern evolution of Jeddah and its the identities and how that came about. Now, some of the traces from there and some of the traces that happened the last 20 years onwards, we may be able to gather some lessons and reflect on what could be some of the formulas that could help and assist in guiding the new developments that are taking place. As you know, there are significant new developments that are taking place in Jeddah, some downtown, the new Midtown project, while already formulated to a large extent, the Kingdom Tower zone. And then we also have all of the potential new developments within the areas that have been vacated within the city. So there's so much potential, and there's the connection grounding that is being conceptualized in a big master plan between the Hazem Palace zone and downtown. So there's so many things that are happening at a large scale. So we wanted simply to open up conversation about how we could look at the notion of identity and the notion of what kind of contemporary language or approach or strategies or devices that could guide our thinking about the architecture of the city of Jeddah. Turkey, I'll leave you to put some thought as well.
Yeah, I think we are moving in a very critical transitional period for the city. The entire majority of the urban center has been, as you said, vacated, and we are looking for new developments to take up that central space in the city. Traditionally, it was identified as the new Jeddah, and during the 60s, it was actually it was under officially under the municipality of New Jeddah, as opposed to the old perimeter of Al Balad. So I think now is an opportunity for us to really question what it is that constitutes a contemporary identity for Jeddah. And obviously, I think with this, when looking at the modern development of the city, you really start to understand how the current metropolitan area of Jeddah formed over time. I think many of Jeddah's inhabitants identify the history of the city with Al Balad, the old walled city. When in the past 80 years, it was actually the old walled city with satellite settlements like Bani Malik, Al-Baghdadiyya, Al-Hindawiyya that lay outside of the walls. And each of these had a specific kind of identity that reflects its local community. And now, once the city started to modernize, a lot of these areas, because of their proximity, became engulfed in a larger metropolitan area. And there you can see that there was a modern language for the buildings that starts to emerge. Now, the question about how do we specify what is the identity of the city, I think, is a complex question that cannot be reduced to a single historical period. And I think now is an opportunity to take that question further as we look forward at the future of these parts of the city. And I think facades really play a key role in the conversation with developers and architects to understand better what is the aspiration for the character of these districts, of these new districts.
Yeah, and now as we look at the new developments and as we look at the subject matter of this particular conference as well, or the setting today, with so many conversations that was talking about the product itself, the technology and the evolution of potential systems that could help us engage environmentally and in creating significant new premises for urban spaces that are potentially protected environmentally as such. You would see how the confluence between the potentials of new technologies that we've heard about today, as well as some other aspects in terms of reinterpreting heritage, relooking at public space, relooking at the notion of ecology and its impact on how we formulate not only the facade of a singular building, but also how does it impact the creation of full neighborhoods and communities, and what are the potential parameters that would help us set some guidelines to create certain levels of, I wouldn't say uniformity, but consistency in terms of the patterns that are being created. You want to talk about the scale and the proportion?
I think, I mean, definitely the facade presents an opportunity to start to guide a sense of harmony between different developments that are adjacent to one another. And this is something that I think that in the vernacular or traditional modes of construction, it becomes a given because because of the limitations of building materials and construction methodologies. So you can see that in Al-Balad, a lot of buildings are similar proportions and they look harmonious together because they are using the same resources and the same skilled labor. Now, contemporary developments, it becomes a bit more challenging because we have a bigger variety, and I think, just from today's conference, you can see, almost endless possibilities for what you can do with facades. But then the question becomes, how can urban design guidelines start to, regulate how different developers or different architects design their buildings, and in a way that is not stifling to the private investor or the intentions of the architect, but at the same time that does not compromise a harmonious reading of the streetscape. And I think that this is one of the major challenges, I think, when we're looking at these mega projects where essentially we're creating entire new neighborhoods from a vacant piece of land. But I think at the same time it's also an opportunity for the developer and the architects that are involved and the investors that are involved to all come together and share a collective vision of what this district can be about, and then using the available technologies in different ways to achieve that vision. And I don't think that it's either, have a very strict building code with a specific color palette for the building skin, or a specific ratio of aperture versus solid versus void, but it can take on a few different variables, and just locking these down to allow for more freedom on other aspects of the design. And I think that could be a successful way to achieve a strong sense of character.
Yeah, I mean, one of the critical things, especially like when you're creating new neighborhoods, as you suggested, is this whole idea of movement. like people's movement, people movement in, say, potentially shaded environments, or wider pedestrian sort of zones versus the vehicular circulation. All of these conversations start addressing the notion of how a building sits and how it faces and interfaces in urban fabric. And that starts adding extra layers to not only the tectonics of the facade, but the spatial transitions that it creates as well. Simply by, let's say, talk about the notion of spatial transitions, shaded networks, walking networks, pedestrian networks, and so on, even if these were become notions of guidelines, and if these simply as principles have been addressed in new developments as part of a code, as part of a guideline, that already gives the fabric of the city, and in consequence, the fabric of architecture, particular elements and particular spatial construct that will affect the identity of how we see. Just like in any towns where you have arcades or where you have shaded streets, the relation between landscape elements and pedestrian movement patterns and so on. So all of these can start describing identities above and beyond, as Turki was saying, specific formal elements and so on. Yeah, so
Yeah, and I think it also speaks to the idea of, facade usually implies a very, like a skin or an outer layer.
Yeah.
When the facade can actually become we can expand the notion of the facade to become more of a three-dimensional building element, where it becomes an occupiable space, and that's also seen in the traditional architecture. I mean, with the ROSHN, it's an extension of, or a protrusion from the building face, and it's an occupiable interface between the street and the interior of the building. So there's a lot of opportunities there, as you said, having arcades, and also I think now we're seeing technologies that also have more interactive facades, like with using elements like that move with the wind, or having projections on the building. So I think it really, there is a lot of opportunity there to engage with the public space and not just think of the facade as something protecting the interior of the building, but also something that's projecting something out as well to the street.
Yeah, I mean, actually I would like to, since we're only two, don't want that to be just a dialogue, meant to be much more than that. I'm going to take advantage of the audience to be the panelists as well. I know, like, we are lucky to have Dr. Hassan Waqid with us, and Mr. Jamil Adra, and many other wonderful people who have given us great insights today. And we would love to hear from you guys any comments that might help further enrich this conversation.
Not working. Yeah, now. Okay. Thank you very much for inviting me to make a quick comment on that used to be exhausted thoughts about the identity and the facades and so on. I've noticed that, that there is forcing ideas that we should go to a certain regulation or system to identify Jeddah identity, especially nowadays where we have technology and we have knowledge that and the environment has been changed and the paradigm shift as well. If we go from the base of that culture we see in the historic area is reflected from a certain demand. Not just that, and even the environment, the social interaction and people. For instance, You know, the privacy was a very important issue to be respected. At the same time that we are in a coastal environment that we need to permit the breeze, the maximum air to come in. And there is aesthetic matters as well, that people love geometric pattern and art and so on. And the people, and especially in Hijaz area, they are, you know, cosmopolitan. They came and they have different capabilities in worth, in terms of worth, in terms of materials, and so that you see the wooden and timber has been there and so on. What I mean that it is a reflection of a need. So we got that beauty over there. This art we've seen around, maybe you can say Indian contributed on that. The art of them you can recognize. And other culture coming in within this city. But I mean, we have a problem so far. Since there is changing or paradigm shift, if we respect that environment which is not similar to any other place, although we are almost within our character, now it is like one village, all the world became like. I mean, it's good if we say that there is a glass can conceal and protect. I mean, if there is, because of the different culture, and ideas of the city, we respect the environment and we try to reflect something in reasoning, having forces of what we should be done. It will create an identity and a character by itself, not forced, because nowadays people are suffering. They cannot have even permission when they go to Baladia and say, give me a license for this project. They say, no, it's not Jeddah. Who can judge this? We have to train those who are looking after or maybe taking the responsibility of giving license or giving permission. So I mean, let us open it, let us have it more scientific, let us have it more reflected to what we have in nature, and something special will be created as well, because the environment is different, people still, the character or the culture is different. So we can have something special as well, but not to be too much, sympathetic with the history as if it is a mandatory element that we can't go beyond. Thank you.
I appreciate your notions at two levels. One of them, the issue of municipal control and municipal assessments that are taking place. And what should there be a broader or a higher level of regulatory bodies that could take over that particular sort of assessments, because it's fundamentally more intellectual, more professional rather than bureaucratic. And what's happening in municipality is fundamentally bureaucratic. I think that's a very critical piece. And the second thing, and I agree with you wholesomely, in such a wholesome manner, that no, the all Jeddah is all Jeddah. All Jeddah and the principles that are engaged and were cultivated within all Jeddah are for all Jeddah. They might not be relevant if you want to create a new development. You looking at best practice from multiple other standpoints, and best practice is global. There are global lessons of what does it mean to have successful neighborhoods, successful public spaces, what kind of architecture is more humane and more relevant to the kind of habitation and facilitates a better quality of living. There are other best practices along the world. I mean, and it's not necessarily that one anthropological reality and its reflection in a certain house form for a certain point in time is still relevant today. Our anthropological realities today, our perceptions of what life is different. So we can't continue to say that's
these are the so I agree with you fully that we have to be very careful in terms of making a distinction between what was pertinent at a moment in time and how we can rethink or think for what is appropriate for today, and what are the best practice points of reference that we can look at regardless of where it's coming from. Now, and the question now is there is a twist in the sense of how civilization is moving these days. I mean, they do say West and East or whatever, or West and the Orient, but it's not the case. What's happening today is that where people are moving is not a question of Westernization. It's a move towards a higher quality of life. And the means by which you create higher qualities of life. And it just happens to be that some of the best practice examples for those are coming from certain areas within the globe. And there's nothing wrong with that. Just like driving a better car or using a better phone or whatever, and so on. At the same time, there are certain aspects that are particular to a place. For example, we were debating about that. Yeah, of course, there are certain. I don't want to call it traditional, because tradition assumes something that is fixed, and I don't want to say that. But there are some social values that we live our day-to-day life with that might be different from how people in other places live, and we have to consider that within a contemporary framework.
And I think also the environment plays a significant role as well. And
I was going to say,
this is this, I think that's the most valuable lesson we can learn from Al-Balad. Is how do we be sympathetic to the environment? How do we use sustainable materials? How do we achieve social sustainability? But I completely also agree that I think fixating on the aesthetics of traditional architecture and making that mandatory for new construction, I think that is going to be detrimental to the character of the city.
100%.
And I think, you're coming from Zohair Faiz, and I think in the 70s when Zohair Faiz was working, and the early 80s, his first project, it was, I think that at that point in time, Jeddah was really, developing and really embracing modernism.
Modernism, yeah.
And you can see that in the character of the buildings.
Yeah.
And I think that's why when I think about the character of the city, I don't need to look only at the historic center, but also to look at this critical period that shaped the identity of the city we all live in today. I don't think that anyone in this room was actually born in a traditional house in Al-Balad, but I think we're all familiar with the modernist buildings. And I think it's a pity that now it becomes, we're taking a step back. And
we're regressing back.
And saying, no, we need to establish a certain character. And I can say also from my small experience with developments that are happening in Ad-Dir'iyah, the urban codes are really put there to reflect a certain character of Ad-Dir'iyah with very specific proportion of openings, paint color, recesses, and some of these guidelines do have, when it comes to spatial organization, they do prioritize pedestrians and creating small pockets of public space. But then when it comes to some of the mandates that enforce a reference to the traditional architecture of the place, that's where it really becomes, redundant. Because even when you go to the local authorities, it's a very, you cannot really debate what constitutes this or that, do we use a ROSHN, or how do we? So I think it becomes problematic. I completely agree.
Yeah, and you know, just to carry on the same, it's not the image of al-balad, it's the universal essences that you could look at and extract. For example, what does it mean to be ecologically responsible? What is a constant in a place other than the its particular environment, its particular ecosystem, and how architecture and how building and how urban form can be developed, can be creatively developed in a manner that is responsive, but at the same time taking every advantage of the affordances of our times in terms of technology, in terms of thought, in terms of impressions in art, in terms of our own evolution as societies and human beings. And this is our challenge, to create a particular identity for us that is authentic to our own times as well, and takes advantage of everything that's in front of us, from best practice to technology to other perceptions. So this is very important, I think. So it is the essences of these principles that allow certain things to be unique at a certain point of time. But that is just something that happened, and how can we be authentic to our own place and our own times as well. This is our challenge, I guess. That's a very critical piece as well, point that is being made.
We have a member of the audience who
please
would like to make a remark.
Please.
Who's first?
Go ahead.
Me?
Yeah.
Okay. Thank you for having me. I am Mohammed Al-Khatib from Andalusia Medical Group, an architect. And actually, I need to touch upon something which is a little bit special. The material selection. We have talked about, the notions, and which was really appreciated, and also the conceptual design regarding the historical places versus the contemporary design, and how to gather or to make this fascinating combination. But regarding the material selection, which which come after, how to create something which is unique, and in the meantime, we do it we create it, respect and follow the historical ethics and those kind of stuff. This is my question: how to select something which creates this contemporary design, as well as respect the historical ethics and, so to speak, the heritage valuing,
I mean, do you want to take this on, or do you want me to touch?
I think, the material selection, I think, at least in our practice, is really part of the initial conceptualization of the design, and it's usually taking material as one of the elements that communicate a story, a narrative about the history and the ecology and place. So whenever we are engaging with a material selection, whether it's for walls, floors, exterior, we usually go through a process of understanding what are locally sourced materials, how can they be reworked for that specific project, and sometimes what is the color palette of the place where we are building, and how does it interface with the natural environment around it, and then using that as a way to introduce contemporary materials. But I think in general, it's I think materiality is one of the is one of the, how can I put this? It's one of the defining factors in the relationship to the locale, because that's since people started building, they use materials from their immediate surroundings, and it's always so it's always interesting to see even the contrast between using contemporary material that comes from outside of the place with local material from that place. And there are technologies that can really create that even almost one-to-one relationship with the ground. For example, when you use round earth, when you use some of the in Riyadh we use Riyadh stone, and these can also become metaphors about. Because when we build today, we cannot claim. It's really difficult to claim that we build all of the building from locally sourced materials. So it also becomes a way to speak about these expanding networks and create a narrative that allows the person who's occupying the space to appreciate what is from the place and what is being brought in from outside. And yeah.
Yeah, I mean, I guess what Turkey is saying, and what Turkey is saying is that we should distinguish between actually building the building out of local materials per se, fully, versus using available materials in a creative way, available local materials in a creative way, to create a sense of association with the place. And these can, depending on the typology of the building. Obviously, if it's like a high-rise, you're not going to go and start using coral stone. But you could use coral stone in the landscape as you enter the building, or in the main lobby as a feature condition, etc. So it becomes an associative device. It's an associative device to the place. Versus if the building type is much smaller habitat, smaller house, and so on, maybe you go all the way and look at a manner by which you use the local stone, etc., whether in a traditional manner or in a very contemporary manner, but fused, where you fuse the contemporary form, a very minimalist form, and so on, with some of the local materials and the local cuts and so on. So there are these distinctions. But what we're saying, I believe, that it becomes more associative, more about creating a story about the place through materiality, not through forms. I guess that's, yeah.
I think it's both. It's forms and materials. Because, these are the types, these are the two elements that are defining our identity. And whenever you are presenting or you need to define a culture, usually you look at the architecture of this culture, and then from the whatever remaining from the architecture of that civilization, you can read it, and you can describe how the people they were living and what were the material that they are using. So regarding the material, I believe that it should be something that is really related to the environment of the city. It should differ from a city to another. And it should be related as well to the urban fabric, that it should be related to the city to give the identity to the city. In these days, we are lucky to see in Riyadh that there is some regulations at the moment related to the Salmani architecture, where the design guidelines are very well set, the setbacks are very well set, the heights, the openings, the color, the material selection, everything. So whenever you are following these design guidelines and you submit your project to get the permit and for the regulations, you don't have somebody who's coming from nowhere and who would like to show you his muscle that he knows much better than you, and then he will reject it. He cannot, because you are following the design guidelines. As if it is, he doesn't have the right to tell you that I want it lower or higher, or put more glass here or less, because there is already some design guidelines in the Salmani architecture, and it starts to be implemented in some district. I'm not saying that the whole city is going to be following the Salmani architecture, but there will be some main vein in the city that they are going to give this identity to the place. Same as you are talking about the Dar'iyya, but Dar'iyya is Dar'iyya, and it has this heritage, heavy heritage on the shoulders that need to be carried. The same what's happening in Al-Balad in Jeddah and in Al-Balad in Riyadh. And as we are, everybody I think know that we are talking about the development of the old city of Yambo as well, the old fisherman city and the old seaport. So all these developments need to be, you know, it's not to recreate the past, no, but using the past to go for the future, using the heritage that we have to build on it, to have proper base for us to keep going without forgetting our identity. We don't want to be like the fast food. Everybody is eating burgers and pizza. No, we should have our own identity. Each city in the country, not only having the high-rise buildings and the glass, with all respect to all the glass manufacturers. So talking about the public spaces and the public realms, by the way, the Ministry of Municipalities and Rural Affairs, they have already issued a memorandum to start taking out all the boundaries and all the gates for the governmental buildings. At the moment in Riyadh, the headquarters of the Municipality of Rural Affairs, Municipalities and Rural Affairs, they took out the boundaries, and the garden surrounding this this building is becoming now public space, public realm for the people to go there and have walkways and just to be the interface. There is no more boundaries between the building, the public realm, and the people. It's going to be one community. So I think that it's going to happen sooner or later in Jeddah as well.
تفضل.
I guess the main issue that first we have to focus on the human needs. What is human needs? People maybe need to feel safe, to feel that the requirement of the place and the function is responding their needs. Because, you know, if you translate, even when you say why this arcade has to be there, some people they may say, maybe it is tradition and it's beautiful that we became familiar with. I say no. It's a sense of refuge. It's a sense of protection. If you go to whatever people appreciate, and as a human being in general, that they say it should be like this or like that, it relates to their background as a human. In terms, even when we say there is a water or there is greenery, you know, it means what? It means that, oh, my food is safe, is available. Water is there, so you feel comfort with this. I think the priority is to look more for the values, added values, and we have to be patriot as well, that we encourage the local products. We have to look first at what is available and encourage the economy. And then after that, we look if it give more values and it elevates the human contentment in general. Last thing I may talk about is that man needs a sense of safety is a very important issue. Self-oriented, that he should feel that in the place that he's welcomed and has function related to him. And mind that something intellectual that through the aesthetic issues or through some matters that makes him thinking and meditating and so on. And a spiritual level that you can give a sense of welcoming and transcendental reaction instead of being just materialistic, and that comes by other elements already. In my study, maybe one day I can highlight it. So it's a lot of issues that it's the human happiness, the quality of life, it's again, the added values. And economy is another value to be considered and to be respected. Thank you.
Turkey, do you want to say a few thoughts and then I'll close if you want?
No, I mean, just reacting to the last two comments, I think that having a human-centered design is obviously very critical, and really understanding the needs, especially when we're working in a wider urban project. And also, I think the idea of guidelines is interesting. What constitutes guidelines that allow for certain freedoms, and what constitutes guidelines that limit the production of the creativity of the architect, or or maybe hinder some of the potential that some developments could have. I think just to add to what Jamil was talking about, I think the working in Al-Ula, looking at their take on urban design guidelines is quite interesting, because it really focuses on materiality and building proportion, instead of the focusing more on traditional forms, because essentially a lot of the traditional architecture doesn't exist anymore in that area. And also I think that ties both comments together in terms of the centering the human around all of these design guidelines. So really, I always appreciate guidelines that can really, when you read them, they can really paint you a picture of how you could walk down the street, instead of something that gives you an aerial view of a whole community and seeing how it looks harmonious. And I think that should take priority over, the God aerial view, which no one ever sees unless you're on an airplane.
Yeah. No, I mean, I liked one aspect from Jamil's conversation. This notion that everything is being opened up to become public realm, which is nice. So the no boundary about institutions and so on, that's a great thing. That's definitely a plus. I would like to close, I mean, just by a few words. I appreciate the notion of memory and how that is important to our souls. Just like you're going into the kitchen, your mom is cooking something with the same smell that your grandmothers have been cooking it, and so on. Just like there is that soulful comfort, in a way, in some of these aspects. Yet, even when your grandmother, to your mother, to maybe you, if you're a great cook as well, you always try to remix something and try to give it a new, fresh look, and you try to fuse it, and you try to do whatever. So we just want to keep this. It's almost like an evolving soul, rather than like something that has already been done and we're just looking at it. So how do you balance? That's very, very, very important. So I'm a bit hesitant to accept the propositions that are coded fully. So I mean, I understand the premise, but there has to be some latitude of how we, and there has to be always a latitude for us to create something absolutely new that has nothing to do with a particular tradition at a particular moment, because there is always a significant value for interruption. When you create something that interrupts a particular rhythm, it makes you more reflective, it makes you more critical, it makes you rethink or think, could I have been doing something different, and why would I do it, and how can we leap rather than just stepping, tiptoeing.
Some of the greatest buildings,
so to speak,
historically interrupt the current paradigm.
Yes. So yeah, so I would say I like the notion of inching your way to Mount Olympus, but sometimes you should leap as well. So there is something so important for us to continue to look more universally to something way beyond what is there in front of us, even what is there at all, and start thinking beyond in terms of aspects that nobody have ever thought about, regardless of where you are in this world. We might be able to create something absolutely different, and that is fine. That's okay. In fact, that's important for us to continue our creative evolution as a culture and as humanity at large as well. Anyways, a few words, I guess, and I don't know. This is a big debate. This is a long debate, and I hope the new opportunities for Jeddah would lead to many experiments rather than a coded point of view. I would say, yeah. Thank you.
Thank you, Nick.
I guess, yeah.
Thank you so much, Dr. Hazem, Turkey. Thank you, Dr. Hassan. Thank you, Jamil. Thank you, member of our audience. Thank you, guys, for participating. The second time we have someone not come and then the audience step in and become participants, which is amazing for this event. I guess I will end this event now, since this was the final participation, final presentation and discussion. I would like to thank all of our speakers. Thank you all to our speakers for their very thought-provoking, excellent discussions, presentations, and first and foremost, thank you to our amazing audience, especially you guys who waited till the end. I hope we all have walked away from this conference with a higher knowledge and a deeper knowledge of facades and how they integrate into our culture and how it can help us build more sustainably. And with this note, I end this conference, and thank you very much, everybody, and drive safe home. Thank you.